For centuries, we've looked up at the stars and wondered, what's out there? And more importantly, how far can we go? From the first steps on the moon to robotic landings on Mars, humanity has begun to stretch its fingers into the vast cosmic ocean. But in the grand scale of the universe, we've barely dipped a toe in the water. What if we dared to go farther? Could humans one day journey beyond our solar system? Could we reach another star, or even another galaxy? And what stands in our way? Technology, time, biology, or something else entirely? In this video, we'll explore just how far our species might go and what it would take to get there. A light year, sometimes written as light year, is not a way to measure time, even though it has the word year in it. Instead, it's a unit used to measure vast distances in space. It tells us how far light can travel in 1 year, and since light is the fastest thing in the universe, that's an enormous distance. According to the International Astronomical Union, 1 light year is the distance that light travels in a vacuum over the course of 1 Julian year, which is 365.25 days. In numbers, that distance is exactly 9,460,073,047,258.8 kilometers. That's about 5.88 trillion miles, a number so big it's almost impossible to imagine. Even though professional astronomers often prefer to use another unit called the parsec, which is about 3.26 light years, the light year is still very popular in books, documentaries, and conversations when people talk about stars, galaxies, and the huge scale of the universe. The idea of using light years started becoming popular after Friedrich Bessel, a German astronomer, made a groundbreaking measurement in the year 1838. He was the first person to successfully measure the distance to a star other than the Sun. The star was called 61 Cygni, and Bessel used a special instrument called a heliometer that had a lens 6.2 inches wide. This instrument had been designed by the famous optician Joseph von Fraunhofer. Back then, the biggest distance unit used by astronomers was the astronomical unit, the average distance between the Earth and the Sun, which is about 150 million kilometers, or 93 million miles. Using a method called trigonometric parallax, and based on how 61 Cygni appeared to shift in the sky by 0.314 arc-seconds, Bessel calculated that the star was about 660,000 astronomical units away. In other words, light from that star took roughly 10.3 years to reach Earth. Even though Bessel mentioned how long light would take to reach us from 61 Cygni, he didn't start using light years as a unit of measurement. He might have avoided it because, at the time, the speed of light was not yet known very precisely, and using it in calculations could reduce the accuracy of his measurements. In the mid-19th century, scientists were still trying to figure out the exact speed of light. Hippolyte Fizeau made a better estimate in 1849, and Léon Foucault improved it again in 1862. People were still trying to understand how light moved through space, especially since many believed in the mysterious ether that was once thought to fill the universe. The term light year first appeared in print in 1851 in a German article written by Otto Uhl, who explained that even though it sounds like a time unit, a light year is a way of describing how far light can go in a year. He compared it to how people sometimes use the term walking hour to mean the distance you can walk in 1 hour. Later on, in 1868, an English journal mentioned that the light year was a unit used by the Germans. Not all scientists liked the term, though the famous British astrophysicist Arthur Eddington once said it was inconvenient and irrelevant, though he admitted it had made its way from popular science into serious scientific discussions. Today, even though scientists still prefer parsecs in professional work, light years are very common in explaining the massive distances between stars and galaxies to the general public. Light years help us picture how far apart things are in space, from the stars near us to the edges of giant galaxies. For example, A typical galaxy can be anywhere from a few thousand to a few 100,000 light-years wide. The space between galaxies, or entire galaxy clusters, can stretch across millions of light-years. Some incredibly distant objects, like quasars or the Sloan Great Wall, a huge structure made of many galaxies, are billions of light-years away. Inside a star system like our own solar system, distances are much smaller, usually just fractions of a light-year. These are often measured in astronomical units instead. But scientists also use other light-based distance units for shorter scales. For example, a light second is how far light travels in 1 second, about 299,792,458 meters. A light minute is 60 times that. A light hour and a light day follow the same pattern. There's even a light month, which is roughly 1/12 of a light year. The Hayden Planetarium defines it more precisely as the distance light travels in 30 days. Interestingly, because light moves so fast, it travels about 1 foot in a nanosecond, a billionth of a second. Some people casually refer to this tiny distance as a light foot. So, while the light year may seem like just a number, it opens a window into the breathtaking size of the universe, helping us grasp just how far away the stars and galaxies truly are. A parsec is a special unit of measurement that astronomers use to figure out how far away stars and galaxies are from us. It's mainly used for objects that are far beyond our solar system. 1 parsec is about the same as 3.26 light-years or 206,265 astronomical units. That's around 30.9 trillion kilometers or about 19.2 trillion miles. That's an incredibly huge distance. The idea of a parsec comes from something called parallax, along with a bit of geometry called trigonometry. To explain it simply, imagine you're looking at a distant star, and you're trying to see how much its position seems to shift when you look at it from 2 different spots. A parsec is defined as the distance from the Sun at which 1 astronomical unit, which is the average distance between the Earth and the Sun, appears to cover an angle of just 1 arcsecond in the sky. 1 arcsecond is a tiny angle. It's just 1 out of 3,600 parts of a degree. To make this clearer, imagine a long, skinny triangle in space. One of the short sides of the triangle is the distance from the Earth to the Sun, 1 astronomical unit. The point opposite this side has an angle of 1 arcsecond. The length of the other side of the triangle, stretching far out into space, is 1 parsec. The closest star to our Sun is Proxima Centauri, and it's about 1.3 parsecs away, which equals about 4.2 light-years. From that far out, the Earth-Sun distance looks tiny, just under 1 arcsecond wide. Most of the stars we can see with our eyes are within just a few hundred parsecs, while the furthest visible ones stretch a few thousand parsecs away. And if you look even farther, the Great Andromeda Galaxy is more than 700,000 parsecs from us. The word parsec is actually short for parallax of 1 arcsecond. It was invented in the year 1913 by a British astronomer named Herbert Hall Turner. He came up with it to make the math for measuring distances in space a little easier. That's why astronomers and scientists who study space prefer to use parsecs. However, in books and shows for the general public, people often still talk in light years, since that term is more familiar. When we talk about even bigger distances in space, astronomers use multiples of parsecs. For example, kiloparsecs, 1,000 parsecs, are used to talk about objects farther away in and around our own galaxy, the Milky Way. Megaparsecs, 1 million parsecs, are used for galaxies that are much farther out. Gigaparsecs, 1 billion parsecs, are for the most distant objects of all, like quasars and faraway galaxies at the edge of the known universe. In August of the year 2015, the International Astronomical Union, IAU, officially stated that 1 parsec is exactly 648,000 divided by pi astronomical units. Based on the IAU's precise definition of an astronomical unit from the year 2012, This means a parsec is about 30.9 trillion kilometers. To understand where this number comes from, picture that same skinny triangle in space again. One side is the Earth-Sun distance, and the angle across from it is 1 arcsecond. Using trigonometry, the math of triangles, we can figure out the length of the far side of the triangle, which turns out to be 1 parsec. One of the oldest and cleverest ways to find out how far away a star is involves measuring how its position appears to shift in the sky over time. Astronomers take one measurement when the Earth is on one side of the Sun, and then wait about 6 months to take another when Earth has moved to the opposite side. The Earth's position shifts by twice the Earth-Sun distance during that time. The change in the star's position helps them calculate something called the parallax angle. With that and a little trigonometry, they can figure out how far away the star is. The first time anyone managed to measure the distance to a star this way was back in 1838. A German astronomer named Friedrich Wilhelm Bessel used this method to measure the distance to a star called 61 Cygni. He found it to be about 3.5 parsecs away, and that was a huge scientific achievement at the time. Imagine you're watching a nearby star while Earth moves around the Sun. Because of this movement, the star seems to shift its position a tiny bit against the background of much more distant stars. This small shift is known as parallax. More precisely, the parallax of a star is defined as half the angle that the star seems to move in the sky during Earth's orbit around the Sun. Another way to think about it is this. If you drew a huge triangle in space with Earth at one point in its orbit, the Sun at the center, and the star at the far end, the parallax angle is the angle seen from the star between the two positions of Earth 6 months apart. That angle is so small that we often measure it in arcseconds. There are 3,600 arcseconds in a single degree. If you replace that 1 arcsecond angle in the triangle with the actual parallax of a star, you can figure out how far the star is from the Sun. The longer side of that triangle, from the Sun to the star, gives us the star's distance. When a star's parallax angle is exactly 1 arcsecond, its distance from the Sun is exactly 1 parsec. So, what is a parsec? It's a unit of distance used by astronomers, and it comes directly from this idea of parallax. The name parsec comes from the words parallax and arcsecond. 1 parsec is the distance at which one astronomical unit, the distance between Earth and the Sun, would appear to be just 1 arcsecond wide. That works out to about 3.26 light years. Using parsecs to measure distances is very convenient. Here's why. If you know the parallax angle of a star, measured in arcseconds, the distance in parsecs is simply the reciprocal of that number. For example, if a star's parallax is 1 arcsecond, it's 1 parsec away. If the parallax is half an arcsecond, the star is 2 parsecs away. If the parallax is 1/10 of an arcsecond, the star is 10 parsecs away. You don't even need to use complex trigonometry, because the angles are so small that a simple triangle approximation works just fine. The word parsec was first used in a scientific paper back in 1913. At that time, the astronomer royal, Frank Watson Dyson, said there needed to be a proper name for this unit of distance. He suggested calling it an astron, while another scientist, Carl Charlier, proposed the name cirriometer. But it was Herbert Hall Turner who suggested parsec, and that's the name that stuck. This parallax method is one of the most basic tools that astronomers use to measure distances in space. However, it has limits. Earth-based telescopes can only measure parallax angles accurately down to about 1/100th of an arcsecond, so they can only measure distances out to about 100 parsecs. That's because Earth's atmosphere makes star images blurry, which limits how precisely we can measure small angles. Space telescopes, on the other hand, don't have to deal with the atmosphere, so they can measure star distances much more accurately and much farther away. Between 1989 and 1993, the European Space Agency launched a satellite called Hipparcos. It measured the positions of about 100,000 stars with amazing accuracy, close to 0.97 milliseconds, and could measure distances up to 1,000 parsecs. Later, on the 19th of December 2013, ESA launched another space observatory called Gaia. Gaia is even more powerful. It's designed to measure distances to about 1 billion stars with an accuracy of up to 20 micro-arc seconds. That's good enough to measure distances with only 10% error all the way to the center of our galaxy, a place around 8,000 parsecs away in the direction of the constellation Sagittarius. Now let's look at some examples to get a better feel for these distances. The distance from the Sun to Earth, known as 1 astronomical unit, is just under 5 millionths of a parsec. The farthest spacecraft ever launched, Voyager 1, was about 0.00007897 parsecs from Earth as of February 2024. It took 46 years to get that far. The Oort cloud, a distant shell of icy bodies surrounding our solar system, is thought to be about 0.6 parsecs in diameter. When astronomers talk about distances between stars, they usually use parsecs. For even bigger distances, like between parts of a galaxy or between different galaxies, they use kiloparsecs, which equal 1,000 parsecs. Here are some more examples. Proxima Centauri, the closest known star to us besides the Sun, is about 1.3 parsecs, or 4.24 light-years away. The Pleiades, a beautiful cluster of stars, is about 130 parsecs from Earth. That's around 420 light-years. The center of our galaxy, the Milky Way, is more than 8,000 parsecs, or 26,000 light-years, away. The Milky Way itself spans about 34,000 parsecs, or 110,000 light-years, across. One of the largest known galaxies, ESO 38376, has a massive diameter of around 540.9 kiloparsecs, or 1.8 million light-years. And our nearest major galactic neighbor, the Andromeda Galaxy, is roughly 780 kiloparsecs, or 2.5 million light-years, from Earth. Astronomers often talk about the distances between galaxies and galaxy clusters using a special unit called the megaparsec. 1 megaparsec is the same as 1 million parsecs, which equals around 3,260,000 light-years. In simpler terms, it's a measure used to describe incredibly huge distances in space, so big that light, traveling at its mind-blowing speed, would take millions of years just to cross them. Sometimes, these distances are written as something like 50 divided by h megaparsecs, or 50 mpch to the power of -1. That might sound confusing, but it's because of a little mathematical helper called h. This h stands for the dimensionless Hubble constant, a number used to deal with the fact that scientists aren't completely sure yet about the exact speed at which the universe is expanding. Usually, this number h falls somewhere between 0.5 and 0.75. It's linked to the real Hubble constant, which measures how fast galaxies are moving away from us. To find distances from the redshift, the stretching of light from galaxies moving away, scientists use a formula that involves the speed of light divided by the Hubble constant, multiplied by the redshift. When astronomers deal with even larger distances, they move up to an even bigger unit, the gigaparsec. 1 gigaparsec is equal to 1 billion parsecs. That's about 3,260,000,000 light-years. This unit is used to talk about some of the largest structures we know of in the universe. In fact, 1 gigaparsec is roughly 1/14 of the way to the edge of the observable universe, which is marked by the faint glow of ancient light called the cosmic microwave background radiation. Gigaparsecs are especially useful when scientists are measuring things like the enormous CFA2 Great Wall, a massive wall of galaxies stretching across the cosmos, the distances between clusters of galaxies, or how far away distant objects like quasars are. Here are a few real examples to help you picture these vast distances. The Andromeda Galaxy, our closest galactic neighbor, is about 0.78 megaparsecs away from Earth. That's around 2,500,000 light-years. The closest big group of galaxies, called the Virgo cluster, is about 16.5 megaparsecs, or 54 million light-years away. There's a galaxy called RxJ 124211, which has a supermassive black hole similar to the one in the center of our Milky Way. It's about 200 megaparsecs, or 650 million light-years from us. One of the largest known structures in the universe, the Hercules Corona Borealis Great Wall, discovered in November of the year 2013, stretches about 3 gigaparsecs across. That's around 9,800,000,000 light-years wide. The furthest boundary we can see, the edge of the observable universe, also known as the particle horizon, is about 14 gigaparsecs away, which equals roughly 46 billion light-years. To figure out how many stars are in our Milky Way galaxy, astronomers select three-dimensional sections of space in different directions. These volumes are measured in cubic kiloparsecs, which are 1,000 parsecs each. All the stars inside those volumes are counted, and from that, scientists estimate the total number across the whole galaxy. They use the same method to estimate how many globular clusters, tightly packed groups of stars, dust clouds, and interstellar gas clouds are floating in our galaxy. To estimate how many galaxies are in gigantic superclusters, astronomers look at volumes measured in cubic megaparsecs. Inside these spaces, every visible galaxy is counted and categorized. Then they use statistics to estimate the total number of galaxies across the universe. This same approach is used to measure enormous empty regions like the Bootes void, a mysterious space nearly empty of galaxies, measured in cubic megaparsecs as well. In the study of the entire universe, which is known as physical cosmology, scientists use even larger volumes, measured in cubic gigaparsecs, to understand how matter, galaxies, and incredibly bright objects like quasars are spread across space. To give you an idea of how empty space can be, in the part of space around our Sun, which is about 1 cubic parsec in size, our Sun is the only star. But in dense star clusters, called globular clusters, there can be as many as 100 to 1,000 stars in just 1 cubic parsec. When it comes to studying gravitational waves, tiny ripples in the fabric of space and time caused by things like colliding black holes, scientists use detectors like LIGO and Virgo. These observatories describe the volume of space they can observe in terms of cubic megaparsecs. That's because the farther away they can detect waves, the larger the cube of space they're effectively listening to. The Moon is the Earth's only natural companion in space, a silent traveler that has been circling our planet for billions of years. It moves around the Earth at an average distance of about 384,000 kilometers, or around 238,000 miles, which is roughly 30 times the width of the Earth itself. One fascinating thing about the Moon is that its journey around the Earth takes the same amount of time as it takes to spin once on its own axis, about 29.5 Earth days. Because of this perfect timing, caused by the Earth's strong gravitational pull, the same side of the Moon always faces us. This is why we only ever see one face of the Moon from Earth. The Moon has a powerful effect on our planet. Its gravitational pull is the main reason we have ocean tides. When the Moon pulls on Earth's water, it causes the sea to rise and fall in a regular rhythm. Even though it's much smaller than Earth, the Moon is still a massive object. It's about 1.2% the mass of Earth, and its diameter, how wide it is from one side to the other, is about 3,474 kilometers, or roughly 2,159 miles. That's about 1/4 the size of Earth, about as wide as the mainland United States. In our solar system, the Moon is special. Compared to its home planet, Earth, it's the biggest moon of all. Out of all the moons orbiting planets in the solar system, the Moon is the 5th largest and 5th heaviest. It's even bigger than many dwarf planets, like Pluto. However, gravity on the moon is only about 1/6 of what we feel on Earth. So if you weigh 60 kilograms here, you'd weigh only 10 on the moon. That's a bit more than the gravity on Mars, but not by much. Only Jupiter's volcanic moon Io has stronger gravity among the moons. The moon is made of rock, much like Earth. It doesn't have any air you can breathe, no oceans or lakes, and no magnetic field to protect it. Scientists believe it was born about 4.51 billion years ago, just shortly after the Earth itself formed. According to the most widely accepted theory, it came to life after a Mars-sized object named Theia crashed into Earth. The collision threw debris into space, and that debris slowly came together to form the moon. The moon's surface is dry and dusty, covered with fine powder known as lunar dust. Its landscape is a mixture of towering mountains, deep craters formed by meteor impacts, streaks of material thrown from those impacts, long grooves called rilles, and dark flat plains known as maria. These maria, which means seas in Latin, aren't made of water. They are fields of ancient lava that cooled and hardened after flowing into deep impact basins on the moon's near side. The sun always lights up half of the moon, except during a lunar eclipse when the Earth casts its shadow over it. But as the moon orbits Earth, we see different parts of its lit-up half, creating what we call the moon's phases, such as the full moon, crescent moon, and new moon. The moon is the brightest object in our night sky, not because its surface is shiny, it reflects light about as well as asphalt, but because it appears quite large from Earth. Its size in the sky almost matches the sun's, which is why the moon can perfectly block the sun during a total solar eclipse. Although we only ever see one side of the moon clearly from Earth, we actually catch glimpses of about 59% of its surface over time, thanks to slight wobbles in its orbit. These wobbles are called libration. The moon has been incredibly important to human history. It has inspired stories, art, religion, and science. It helped early people track time and understand the heavens. It was also the first place in space where humans sent machines. In the year 1959, the Soviet Union sent Luna 1 past the moon, and Luna 2 purposely crashed into it. In 1966, Luna 9 became the first spacecraft to land softly on the moon, and Luna 10 was the first to orbit it. Then came a moment that changed history. On July 20th, 1969, humans walked on another world for the very first time. The United States Apollo 11 mission landed in an area called Mare Tranquillitatis, the Sea of Tranquility. The astronauts came down in a lander called Eagle and left footprints on the moon's dusty ground. 5 more missions followed, ending in 1972, and in total, 12 men walked on the moon. The longest stay lasted 75 hours, made by the Apollo 17 crew. Since then, the moon has been explored by robotic spacecraft, and new crewed missions are being planned to begin again in the late 2020s. The proper English name for our moon is always written with a capital M, moon. The word moon itself comes from the Old English word mona, which came from older languages like Proto-Germanic menon and the ancient Proto-Indo-European word mensis, which meant month. That's because the moon's cycles were once how people measured time. Sometimes, especially in science fiction or scientific texts, the moon is called luna, a word borrowed from Latin. Poets have also called it Luna, as well as Cynthia and Selene, names drawn from ancient myths. In Greek mythology, Selene was the goddess of the moon, and her name literally means moon. Cynthia was another name for the goddess Artemis, who was linked with the moon and born on Mount Cynthus. The Roman version of Artemis was Diana. The word lunar is the English adjective used to describe anything related to the moon. A rarer word, Selenian, describes the moon as a world of its own and comes from the Greek word selene. Even the chemical element selenium got its name from this root. Words like selenography, which means the study of the moon's surface, also come from the same source. The moon has its own symbols in astronomy, usually drawn as crescent shapes, either waxing or waning. Lunar geology divides the moon's history into periods named after the kinds of craters and lava plains that dominate each age. Some of the youngest and brightest craters, like Copernicus or Tycho, still have visible rays of debris spreading out from them. By studying rocks brought back from the moon, scientists think it formed around 50 million years after the solar system began. Over the years, many theories have tried to explain how the moon came to be, but most fall short. Some said the moon was flung off the Earth by spinning too fast, though Earth would have had to spin much faster than possible. Others believed it was a passing body that Earth captured with its gravity, but this would have required a thick atmosphere that Earth never had. A third idea was that Earth and the moon formed together side by side, but that doesn't explain why the moon has far fewer metals. The most accepted idea today, the giant impact theory, is the one that best explains how the Earth-Moon system came to have such high energy and such a special relationship. Most scientists today believe that the Earth and the Moon were created from a massive cosmic collision that happened more than 4.5 billion years ago. Back then, the Earth was still very young and not fully formed. A huge object about the size of the planet Mars, now called Theia, crashed into this early version of Earth. The impact wasn't head-on, but more of a glancing blow, which caused an enormous amount of rock and debris to be thrown into space, just beyond a certain distance known as the Roche limit, which is a bit more than 2.5 times the Earth's radius. Over time, this floating debris came together, or accreted, and formed what we now know as the Moon. These kinds of giant crashes were quite common in the early days of our solar system. Scientists have run computer simulations of such events, and these support the idea. The results match the current mass of the Moon's core and the way the Earth and Moon move together. Interestingly, these simulations also suggest that most of the Moon's material came from Theia, not the Earth. But starting around the year 2007, newer models have shown that more of the Moon's material might actually have come from the Earth instead. When scientists studied rocks from other planets like Mars and the asteroid Vesta, they found that these bodies have very different types of oxygen and tungsten atoms compared to Earth. However, Earth and the Moon have almost identical versions of these atoms, which is strange if the Moon mostly came from Theia. One possible explanation is that after the impact, the Earth and the Moon were both surrounded by a huge cloud of vaporized rock that mixed together completely, making their atomic makeup nearly the same. Still, not everyone agrees with this idea, and it remains a topic of debate. The force of the collision would have released an incredible amount of energy, enough to melt the outer layers of both the Earth and the debris that formed the Moon. This would have created oceans of molten rock or magma on both bodies. The Moon's own magma ocean might have been between 500 and 1,700 kilometers deep. That's about 300 to over 1,000 miles. The giant impact theory explains many things about how the Earth and Moon behave today, but there are still unanswered questions. One puzzle is the Moon's composition. If a lot of its material came from the Earth, then some of the chemical data, like the types of zirconium, oxygen, and silicon atoms in moon rocks, doesn't quite match up. However, a very detailed simulation published in the year 2022 used over 100 million virtual particles to show that a moon-like satellite could form instantly during such an impact. Even if it started out too close to Earth, within the Roche limit, it could survive by getting pushed into a stable orbit farther away. Then, on the 1st of November 2023, scientists revealed new computer models suggesting that parts of Theia might still be buried deep inside the Earth. When it first formed, the Moon was much closer to the Earth than it is now. Because of this, the Moon would have looked huge in the sky, and the Earth would have looked huge from the Moon. Eclipses would have been more common, and the gravitational pull between the two was much stronger. Over time, this strong pull, called tidal acceleration, pushed the Moon farther away and made its orbit longer. As time passed, the Moon cooled down, and most of its thin atmosphere disappeared. Its surface was then shaped by countless impacts, big and small, creating the crater-filled landscape we see today. Surprisingly, the Moon stayed volcanically active until about 1,200,000,000 years ago. These volcanic eruptions formed the dark plains we see on the Moon's surface, known as the lunar maria. Most of this volcanic activity happened between 3,300,000,000 and 3,700,000,000 years ago. But some lava flows are as young as 1,200,000,000 years, and some are as old as 4,200,000,000 years. Scientists still aren't sure why most of these volcanic plains appear only on the side of the Moon that faces the Earth. One theory is that large impacts on the near side broke through the thinner crust there, allowing lava to rise more easily to the surface. The Moon's shape is not a perfect sphere. It's slightly stretched due to Earth's gravity, forming what's called a scalene ellipsoid. But the long axis of the Moon doesn't point directly at Earth. It's off by about 30 degrees, probably because of the large basins formed by ancient impacts. Interestingly, the Moon is more stretched out than today's gravity would cause, which suggests that this shape is a sort of fossil from a time when the Moon was much closer to the Earth and still molten. Now that it's cold and solid, its shape can no longer adjust to current forces. In size, the Moon is the fifth largest natural satellite in the solar system. It is small compared to the Earth, but still quite large in its own right, bigger than the dwarf planet Pluto, and only smaller than Mercury among the rocky worlds. In fact, compared to the planet it orbits, the Moon is the largest moon in the solar system. The Moon's diameter is about 3,500 kilometers, which is more than 1/4 the width of Earth. To put it another way, the Moon's face is about as wide as mainland Australia, Europe, or the contiguous United States. Its total surface area is about 38 million square kilometers, roughly the size of both North and South America combined. The Moon's mass is about 1/81st that of Earth. It has the second highest surface gravity of all the moons in the solar system. Only Jupiter's moon Io has more. The Moon's gravity is about 1/6 of Earth's, and to escape its pull, a spacecraft needs to travel at over 8,600 kilometers per hour, or more than 5,300 miles per hour. Inside, the Moon has a layered structure similar to Earth. It has a solid inner core made mostly of iron, which may be only about 240 kilometers across. That's 150 miles. Around this is a liquid outer core about 300 kilometers wide, made mostly of molten iron. Beyond that is a partially melted layer, about 500 kilometers thick, which separates the core from the rocky mantle. Scientists believe that this structure formed after the Moon's surface cooled and hardened, while the inside remained hot and molten. As the molten rock slowly cooled, heavier minerals like olivine and pyroxenes sank down to form the mantle. Lighter minerals like plagioclase floated up to form the crust. The very last parts to solidify got trapped between the crust and mantle, rich in rare and heat-producing elements. Maps made from lunar orbit show that the crust is mostly made of a light-colored rock called anorthosite, which supports this idea. Samples of moon rock brought back by astronauts also confirm that the Moon's mantle is rich in iron, more so than Earth's. On average, the Moon's crust is about 50 kilometers thick. That's roughly 31 miles. The Moon is the second heaviest satellite in our entire solar system, right after Io, one of Jupiter's moons. But even though the Moon is heavy overall, its inner core is actually quite small. This core stretches only about 350 kilometers, or around 220 miles, across. That means it's just 1/5 the size of the whole Moon. Scientists still aren't completely sure what it's made of, but they think it mostly contains metallic iron mixed with a bit of sulfur and nickel. Studies of how the Moon spins and how that spin changes over time suggest that at least part of this tiny core is still molten or in a melted state. The pressure deep inside the Moon's core is also immense, about 5 gigapascals, which equals around 49,000 times the pressure of Earth's atmosphere at sea level. If you were to walk on the moon, you'd feel much lighter than on Earth. That's because gravity on the moon's surface is much weaker. It's only about 1/6 as strong as Earth's gravity, or to be exact, 1.62 meters per second squared. That's also about half the gravity you'd feel on Mars. Interestingly, the moon's gravity isn't even across its surface. In some places, it pulls more strongly than in others. Scientists discovered this by carefully studying the radio signals sent by spacecraft flying around the moon. These signals shift in frequency slightly, a phenomenon called the Doppler effect, as the spacecraft moves through areas of stronger or weaker gravity. They found that certain large regions on the moon, especially around the giant impact basins, have something called mascons, short for mass concentrations. These are spots where gravity is unusually strong. This is partly because those areas are filled with heavy volcanic rock called basalt, which flowed into the basins long ago. But these dense lava flows don't fully explain the extra gravity. In fact, some mascons exist where there's no volcanic activity at all, and that still puzzles scientists. When it comes to magnetism, the moon is almost silent. Its magnetic field is incredibly weak, less than 0.2 nanoteslas, which is over 100,000 times weaker than Earth's magnetic field. It also doesn't have a strong, global magnetic field like Earth's. Instead, only parts of the moon's crust are magnetized, and these areas likely got their magnetism early in the moon's life, when it may have had a magnetic dynamo. About 4 billion years ago, the moon's magnetic field may have been as strong as Earth's is today. But over time, as the moon's core cooled and hardened, this dynamo faded away, probably around 1 billion years ago. Some leftover magnetism may have come from powerful impacts, which sent out expanding clouds of plasma in the presence of a magnetic field. Interestingly, the strongest magnetic spots are found on the opposite side of the moon from where the biggest asteroid impacts happened, adding weight to this theory. Now, what about the moon's atmosphere? Well, it hardly has one at all. It's so thin and wispy that scientists call it an exosphere, and its total mass is less than 10 tons. The pressure from this tiny atmosphere is unbelievably low, about 3 times 10 to the power of -15 atmospheres, or just 0.3 nanopascals. This pressure changes depending on whether it's day or night on the moon. The gases in the exosphere come from 2 main sources: outgassing from inside the moon and sputtering, where atoms are knocked off the surface by solar wind particles. Scientists have found sodium and potassium in the moon's exosphere, as well as helium-4 and neon from the solar wind. Radioactive decay deep inside the moon also releases gases like argon-40, radon-222, and polonium-210. Strangely, some elements that exist in the moon's soil, like oxygen, carbon, and hydrogen, don't appear in its atmosphere, and no one knows exactly why. Water has been found on the moon too, but not in lakes or rivers. Lunar water shows up as vapor, and it seems to be more common at certain latitudes, especially between 60 and 70 degrees. Scientists believe this water might come from ice buried in the moon's soil, which turns directly into vapor when warmed by sunlight. These gases don't hang around for long. Some are pulled back down into the moon's surface by gravity, while others drift off into space, either pushed by sunlight or swept away by the solar wind if they become electrically charged. Long ago, though, the moon wasn't always so empty. Rock samples from the Apollo missions tell us that the moon once had a much thicker atmosphere. Between 3 and 4 billion years ago, it may have kept this atmosphere for about 70 million years. Back then, powerful volcanic eruptions released huge amounts of gas, creating an atmosphere twice as thick as what Mars has today. But over time, solar wind blew it away into space, leaving the moon with just its thin exosphere. There's also something fascinating floating above the moon right now: a permanent cloud of dust. Tiny particles from comets hit the moon's surface, around 5 tons of material every 24 hours, and this impact sends lunar dust flying upward. Each dust particle stays aloft for around 10 minutes, rising for 5 minutes and falling for 5 more. At any given time, about 120 kilograms of dust hangs in this invisible cloud, floating up to 100 kilometers above the surface. The dust cloud isn't even. It's thicker near the edge where the moon's day and night meet. During meteor showers like the Geminids and Quadrantids, even more dust flies into the moon's skies. The moon is also bombarded by radiation. The sun, cosmic rays, and neutron radiation expose the moon to an average of about 1.37 millisieverts of radiation each day during daylight hours. That's around 2.5 times more than what astronauts face on the International Space Station, 5 to 10 times more than what passengers experience during a long airplane flight, and 200 times more than the radiation we get on Earth's surface. For comparison, a journey to Mars exposes travelers to about 1.84 millisieverts per day, and being on Mars itself would expose someone to around 0.64 millisieverts per day, sometimes even less. The sun's energy also gives the moon's dust an electric charge, making it float and stick to everything. This charged dust can be extremely harmful, damaging machines and even lungs if it ever got inside a habitat or spacesuit. Lastly, let's talk about the moon's tilt. The moon doesn't tilt much on its axis, just a little more than 1.5 degrees compared to Earth's tilt of over 23 degrees. Because of this, the moon doesn't really have seasons like we do. But this small tilt does lead to something amazing. Certain high spots near the moon's north pole, like the rim of Peary Crater, receive sunlight almost all the time. These peaks of eternal light may someday be perfect spots for future moon bases powered by solar energy. The surface of the moon experiences extreme temperature changes, swinging wildly between burning hot and freezing cold. When a part of the moon is in direct sunlight, the temperature can soar up to about 120 degrees Celsius. But in the shadowy areas, where the sun never reaches, temperatures can plunge all the way down to around -171 degrees Celsius. Since the moon has no atmosphere to trap heat or spread it around, the temperature depends almost entirely on whether a place is in sunlight or shade. Because of this, the moon's hills, valleys, and craters play a big role in how hot or cold a certain area gets. Some of the moon's craters, especially those near the north and south poles, have bottoms that are always in shadow. These places, sometimes called craters of eternal darkness, are among the coldest spots in the entire solar system. NASA's Lunar Reconnaissance Orbiter spacecraft found that in the southern polar craters during summer, temperatures dropped to just 35 Kelvin, that's about -238 degrees Celsius. Even colder temperatures were recorded during the northern winter in a crater named Hermit, where it reached an astonishingly low 26 Kelvin, or around -247 degrees Celsius. That is even colder than the surface of Pluto, making it the coldest place ever measured by a spacecraft. Covering the moon's surface is a layer of loose, dusty material called regolith. This layer was formed by billions of years of meteoroid impacts smashing rocks into smaller and smaller pieces. The regolith is mostly grey and fine, and it feels a bit like powdery snow. It even has a strange smell that some astronauts described as being similar to burnt gunpowder. This layer is thicker in older areas, about 10 to 15 meters or 33 to 49 feet deep in the highlands, and thinner in younger, smoother regions called Maria, where it's around 4 to 5 meters or 13 to 16 feet deep. Below this soft layer lies the megaregolith, which is a deep layer of fractured rock extending many kilometers beneath the surface. Because of the moon's harsh environment, no atmosphere, intense radiation, and extreme temperatures, it's highly unlikely that any bacterial spores from Earth could survive there for more than one full orbit of the moon. Scientists have studied the moon's shape and surface using tools like laser mapping and stereo images. One of the most impressive features is the South Pole Aitken Basin, located on the far side of the moon. This huge impact crater is about 2,240 kilometers, around 1,390 miles, wide. making it the largest crater on the Moon and the second largest confirmed crater in the solar system. It is also incredibly deep, reaching down about 13 kilometers or 8.1 miles. The very lowest point on the Moon's surface lies inside a smaller crater within this basin, at over 9 kilometers below the average lunar surface. On the other hand, the highest point on the Moon, sometimes called the Selenian summit, rises more than 10 kilometers or about 6.5 miles above the average surface and is located northeast of the South Pole Aitken Basin. Scientists believe that the powerful impact that created the basin may have pushed up this elevated area. Other massive craters, such as Imbrium, Serenitatis, Crisium, Smithii, and Orientale, also show unique features: low centers and high raised rims. Interestingly, the far side of the Moon is, on average, about 1.9 kilometers, or 1.2 miles, higher than the side we can see from Earth. Another fascinating discovery is that the Moon is actually shrinking. Yes, very slowly. Scientists found signs of this in the form of fault cliffs, which suggest that the Moon has shrunk by about 90 meters, or around 300 feet, over the last billion years. This happens because, as the Moon cools down over time, its surface contracts and cracks. One area, Mare Frigoris, once thought to be geologically inactive, shows signs of recent cracking and movement. In 2010, NASA's Lunar Reconnaissance Orbiter captured images revealing a cave near the Sea of Tranquility, close to the famous Apollo 11 landing site. This cave is actually the opening of a collapsed lava tube. It's about 45 meters, or 148 feet, wide and up to 80 meters, or about 262 feet, long. What makes it especially exciting is that the temperature inside remains steady at around 17 degrees Celsius. This is much more comfortable compared to the extreme temperatures outside, making it a promising place for future astronauts to live or take shelter. However, reaching the cave could be tricky, and there are potential dangers like cave-ins or falling rocks. When we look up at the Moon from Earth, we can see dark, flat areas that early astronomers thought were seas. These are called maria, the singular is mare, and they are actually large plains made of hardened lava from ancient volcanic activity. These lava flows filled the huge basins left behind by impacts long ago. While the lava is similar to what we find on Earth, it contains more iron and doesn't have minerals that were changed by water. The largest area of this type is called Oceanus Procellarum, or the Ocean of Storms, and it stands out because it doesn't seem to be linked to any major impact crater. As the lava cooled and shrank, it created ridges called wrinkle ridges, long, wavy lines that can stretch for hundreds of kilometers. These ridges often trace hidden features buried under the surface. Along the edges of the maria, the lava sometimes caused the ground to sink inward, creating curved cracks known as arcuate rills. There are also hidden maria, called cryptomares, that were buried by debris from later impacts. These are probably older than the maria we see today. In contrast, some pools of melted rock from impacts were later covered by lava. Where we can still see these impact melts, they look different from lava flows in terms of brightness, location, and texture. Some winding features on the Moon called sinuous rills are believed to be the paths of long-gone lava rivers or collapsed lava tubes. They usually start at volcanic vents and twist and turn across the surface. Some of the biggest examples, like Schroeter's Valley and Rima Hadley, are much bigger and deeper than similar features on Earth. They even have sharp curves and bends that are not often seen in Earth's lava flows. Volcanic activity on the Moon, especially in the dark plains called maria, has changed many of its craters over time. In some places, lava from inside the Moon flowed up and filled these craters, making their floors rise and sometimes even crack from the pressure below. Craters like Taruntius and Gassendi are good examples of this, but not all craters were caused by impacts from space. Some, like Hyginus, were created by volcanic activity alone. These craters are formed when the ground collapses, creating a pit or a depression. These types of volcanic craters are rare and tend to be much smaller, usually just a few kilometers wide, shallower, and more uneven in shape. They also don't have the raised edges or rims that are typical of impact craters. On the side of the Moon that always faces Earth, known as the near side, scientists have found several areas with small volcanoes shaped like shields and domes. There are also places where explosive eruptions left behind piles of ash, cinders, and lava with a thick, sticky texture. Some of this lava is different from the usual basalt and is made of thicker, slower-flowing material. Almost all the Maria are on the near side of the Moon. In fact, they cover about 31% of that side, compared to just about 2% on the far side. Scientists believe this is because the near side has more heat-producing elements underneath the surface. These elements warmed up the layer beneath the crust, called the mantle, causing it to partially melt. This melted rock then rose to the surface and erupted, forming the Maria. Most of these lava flows happened during a time called the Imbrian period, between 3.3 and 3.7 billion years ago. But some eruptions may have happened as recently as 1.2 billion years ago, while others go back as far as 4.2 billion years. In the year 2006, scientists studying a small dip in a region called Lacus Felicitatis found sharp, clean features that didn't seem to have much dust on them. Because they looked so fresh and untouched by falling debris, these features might be only about 2 million years old. This, along with moonquakes and gas being released from underground, suggests that the Moon may still have some volcanic activity going on. In fact, scientists have found 70 unusual volcanic areas, known as irregular mare patches, that could be less than 50 million years old. This points to the possibility that the Moon's interior, at least on the near side, might be warmer than we thought. In one crater called Lowell, located inside the Oriental Basin, signs of volcanic activity only 2 to 10 million years old have been discovered. One possible explanation is that the Moon's mantle started out hotter than expected, or that certain areas had more radioactive material, which kept them warm longer, even on the far side of the Moon. The lighter-colored areas of the Moon are called terrae, or more commonly, highlands. These regions are higher in elevation than the Maria and are some of the Moon's oldest surfaces. They were formed about 4.4 billion years ago and are likely made of a mineral called plagioclase, left behind when the Moon's surface was still a molten ocean of magma. Unlike Earth, the Moon's mountains didn't form from tectonic movements. The reason the Maria are mostly on the near side may also have to do with the crust. The crust on the far side is much thicker, especially in the highlands. Some scientists think this happened because, long ago, the Earth had a second smaller moon that slowly crashed into the larger one, causing this difference in crust thickness. Another theory is that when the Moon was closer to Earth, the heat from the Earth affected the Moon more on one side than the other, causing uneven heating inside. One of the biggest forces shaping the Moon's surface is impact cratering. These craters form when space rocks, like asteroids or comets, slam into the Moon. It's estimated that the near side of the Moon has around 300,000 craters that are wider than 1 kilometer. Depending on their size, craters look different. Small craters are bowl-shaped with raised rims. Larger ones have flat floors, terraced walls, and sometimes even central peaks. The biggest of all are multi-ring basins, with 2 or more rings of mountains circling the center. While most craters are round, some look more angular or stretched out. For example, craters like Cantor and Janssen have shapes that might be influenced by cracks or faults beneath the surface. Others, like the Messier pair or Schiller, look elongated, possibly because the impacting object came in at an angle, broke apart, or was part of a double impact. The history of the Moon is recorded in its craters. Scientists use the biggest and most noticeable impact sites, like the Nectaris, Imbrium, and Orientale basins, to mark the major events in the Moon's timeline. These massive craters are surrounded by debris and create layers in the Moon's surface, helping scientists figure out which parts are older or younger. Because the Moon has no weather, no wind, and no recent major geological activity, many craters have stayed almost perfectly preserved for billions of years. By counting how many craters exist in an area, scientists can estimate how old that surface is. But they have to be careful. When one large impact happens, it can spray out smaller pieces of rock that make secondary craters far away. Rocks collected during the Apollo missions show that many impact-melted rocks are between 3.8 and 4.1 billion years old. This suggests that the Moon went through a period of intense bombardment called the Late Heavy Bombardment. Modern spacecraft, like the Lunar Reconnaissance Orbiter, have taken high-resolution photos that show new craters are forming more often than we used to think. Tiny impacts, along with debris scattered from larger ones, can churn up the top 2 centimeters of lunar soil every 81,000 years. That's about 100 times faster than older models predicted using only micrometeorite impacts. The Moon also has some mysterious patterns on its surface known as lunar swirls. These swirls are bright, curly designs that look newer than the surrounding ground. They often show up in places with strong magnetic fields, and many are located directly opposite major impact sites. The most famous of these is the Rhina Gamma swirl. Scientists think these bright patches may be areas protected from solar wind, which slows down the weathering process. Liquid water can't survive on the Moon's surface. When water is exposed to sunlight there, it breaks apart and escapes into space. But since the 1960s, scientists have thought that ice might exist in dark craters at the Moon's poles. These places are always in shadow and incredibly cold. Ice could have arrived from comets or formed through chemical reactions between lunar rocks and hydrogen from the solar wind. Some computer models suggest that as much as 14,000 square kilometers, about 5,400 square miles, of the Moon's surface may be in permanent shadow. Finding usable water on the Moon would be very helpful for future lunar bases, as it would save the huge cost of bringing water from Earth. Over the years, scientists have found more and more clues that water might exist on the Moon. One of the first major hints came in the year 1994, when a special radar experiment aboard the Clementine spacecraft found what looked like small frozen patches of water near the surface. However, later observations using the powerful Arecibo radar raised doubts about this discovery. Those results suggested that the reflections might not be from ice, but from rocky material that had been thrown out of young impact craters. Then, in the year 1998, the Lunar Prospector spacecraft used a tool called a neutron spectrometer to look for hydrogen near the Moon's poles. Hydrogen is often found in water, and it turned out there were high amounts of it in the top 1 meter of lunar soil, which scientists call regolith. This added more weight to the theory that water might be hiding in these colder, darker regions. Even earlier, during the Apollo 15 mission, astronauts brought back small glassy beads formed by ancient volcanic activity on the Moon. When scientists examined these beads, they found tiny amounts of water trapped inside them. This showed that water had been present in the Moon's interior long ago. In 2008, India's Chandrayaan-1 mission made a huge breakthrough. It carried a tool called the Moon Mineralogy Mapper, which could study the minerals on the Moon's surface by analyzing how sunlight bounces off them. This device detected patterns in the light that suggested the presence of hydroxyl and water molecules. It also found that, in some areas, the amount of water might be as high as 1,000 parts per million. Then, in the year 2018, further studies using the mapper showed clear evidence of water ice in places that never see sunlight, deep in the shadows near both the North and South poles. In 2009, NASA sent a spacecraft called L-Cross to crash into a permanently shadowed crater near the Moon's pole. The impact threw up a cloud of material, and scientists found at least 100 kilograms, over 200 pounds, of water in the debris. Later studies even increased that estimate to around 155 kilograms, give or take 12 kilograms. In May of 2011, scientists made another exciting discovery. They studied a sample of lunar soil known as orange glass soil, which was collected during the Apollo 17 mission way back in 1972. This soil was formed during explosive volcanic eruptions about 3.7 billion years ago. Tiny bits of this material, called melt inclusions, were found to contain between 615 and 1,410 parts per million of water. This amount is similar to the water found in the Earth's upper mantle. But here's the catch. These water-rich inclusions were located deep underground and were so small and hard to find that it took nearly 4 decades and a very advanced instrument to detect them. In August of 2018, more detailed analysis of the Moon Mineralogy Mapper confirmed the strongest evidence yet: actual water ice on the Moon's surface. This ice was not just a guess or a hint. It had a clear signature different from regular dust or other reflective materials. The ice was found at both poles, especially the South Pole, where it hides in permanently shadowed craters. These cold, dark spots keep the ice from melting because sunlight never reaches them. Then, in October of 2020, scientists made a surprising discovery. They detected molecular water on the sunlit side of the Moon. This was thanks to data from various spacecraft, including a flying observatory called SOFIA, Stratospheric Observatory for Infrared Astronomy. This was the first time that actual water molecules, not just signs of hydroxyl, were confirmed in areas exposed to sunlight. The Earth and the Moon are not just neighbors, they actually form a kind of team, orbiting a shared center of mass called the barycenter. This point lies about 1,700 kilometers, or roughly 1/4 of the Earth's radius, beneath the surface of our planet. The Moon doesn't travel in a perfect circle around Earth. Its orbit is slightly stretched, forming an oval shape. Scientists call this a slightly elliptical orbit, and it has a small eccentricity of 0.055. The average distance between the Earth and the Moon is about 400,000 kilometers, or 250,000 miles, which is about the same as going around the Earth 9.5 times. The Moon takes around 27.3 days to orbit Earth completely if you measure it against the background stars. But because the Earth and Moon are also moving together around the Sun, it takes a little longer, about 29.5 days, for the Moon to return to the same phase, like full moon to full moon. This longer period is called a synodic month and is the same length as one day on the Moon. Now here's something interesting. The Moon always shows the same face to Earth. This happens because it spins once on its axis at the same time it takes to orbit Earth once. Scientists call this tidal locking. But we don't always see exactly the same part of the Moon. Because of small wobbles in its motion, known as libration, we can actually see up to about 59% of its surface over time from Earth. Unlike most moons, which orbit around the equators of their planets, the Moon's path is tilted more toward the plane of Earth's orbit around the Sun. This tilt, along with the tug of gravity from both the Earth and the Sun, causes some complicated effects on the Moon's motion. For example, the plane of the Moon's orbit rotates very slowly, completing a full turn once every 18.61 years. These changes in motion were described long ago by the astronomer Giovanni Cassini and are known as Cassini's laws. The Moon doesn't just move quietly through space, it pulls on Earth, and Earth pulls back. These gravitational forces are stronger on the sides closest to each other, which causes tidal forces. We mostly notice these as ocean tides, but the Moon's pull also affects the solid ground and other natural systems. Even the Moon's rocky crust rises and falls a little bit, about 10 centimeters or 4 inches, during each lunar cycle. This happens due to a combination of steady pull from Earth, changes in the Moon's distance and tilt, and a small added effect from the Sun. And here's a fascinating possibility. Some researchers now believe that the Moon might help Earth maintain its magnetic field, which protects our planet from harmful solar radiation. If true, it would mean that the Moon's influence on Earth is even more important than we once thought. Over time, the constant pull and push caused by the Moon's gravity creates stress in the Moon's crust. When this stress builds up enough, it can trigger small tremors called moonquakes. These moonquakes are not as common or strong as the earthquakes we feel on Earth. However, what makes them special is that they can last much longer, up to 1 full hour. This is because the moon's upper crust is dry and broken into pieces, which causes the vibrations to bounce around and take longer to settle down. The surprising discovery of moonquakes came from instruments called seismometers that were placed on the moon by Apollo astronauts between 1969 and 1972. The most familiar effect of the moon's gravity on Earth is the rise and fall of ocean waters, known as tides. These happen because of tidal forces. While the moon is the main cause of tides, the sun also plays a role. In fact, the sun's pull adds nearly 40% of the force that the moon provides. The way the sun and moon work together causes the patterns we know as spring tides and neap tides. Tides are created by 2 large bulges of water in the Earth's oceans. One bulge is on the side of the Earth that is facing the moon, and the other is on the opposite side. As the Earth spins, these bulges move around the planet. The bulge that's closer to the moon happens because the moon's gravity pulls the water toward it. The bulge on the far side happens either because of a balancing force called centrifugal force, or because the moon's gravity pulls the Earth slightly more than the distant water, leaving that water behind. This process creates 2 high tides and 2 low tides about every 24 hours. However, because the moon is slowly moving in the same direction that the Earth rotates, the high tides happen about every 12 hours and 25 minutes, not exactly 12 hours. That extra 25 minutes is caused by the moon's own movement around the Earth. If our planet were completely covered in water with no land masses, the tides would be much simpler. They would rise and fall by only about 1 meter, and the timing would be easy to predict. But real Earth is much more complicated. Here's why. Water rubs against the ocean floor, slowing it down. This is called frictional coupling. Water keeps moving due to its inertia even after the moon's pull changes. Ocean basins become shallower near continents. Water moves back and forth between different ocean basins, like sloshing in a giant bowl. Because of all this, the actual times and heights of tides are best learned by observing them, even though scientists have theories to explain how they work. As tides rise and fall, they create friction that slightly resists the Earth's rotation. This slows down the Earth's spin, gradually taking away some of its rotational energy. But that energy doesn't disappear. It is transferred to the moon. This transfer pushes the moon into a higher orbit and makes it move more slowly around the Earth. This process is called tidal acceleration. As a result, the distance between the Earth and the moon is slowly increasing, and the Earth's rotation is gradually slowing down. Scientists have confirmed this by measuring the distance between the Earth and the moon using mirrors left behind by the Apollo astronauts. These experiments show that the moon is drifting away at a rate of about 38 millimeters per year, which is about as fast as your fingernails grow. Meanwhile, atomic clocks, which are incredibly accurate, have shown that Earth's days are getting longer by about 17 microseconds per year. This is why we occasionally need to add leap seconds to our clocks to keep them in sync with Earth's slower rotation. Over a very long time, this process will cause the Earth's rotation and the moon's orbit to become synchronized, a state called tidal locking. We already see this happening with the moon, which always shows the same face to the Earth. In theory, in about 50 billion years, the Earth will also rotate at the same speed that the moon orbits, meaning both bodies will always show the same side to each other. However, we don't need to worry about that happening, because the sun will turn into a red giant long before then and will likely swallow the Earth and moon together. But let's imagine that doesn't happen. If the Earth-Moon system survives, then over time the sun's outer atmosphere could still slow down the moon's orbit, making it move closer to Earth. If the moon ever comes within about 18,470 kilometers, about 11,480 miles, it would reach a point called the Roche limit. At this point, the moon would be torn apart by Earth's gravity, creating a ring of debris around the planet, like the rings of Saturn. Most of this debris would eventually fall to Earth, possibly leaving our planet without a moon. The height of the moon in the sky changes depending on its phase, how much of it we can see, and the time of year. For example, the full moon is highest in the sky during winter and lowest during summer, depending on whether you're in the northern or southern hemisphere. At the North and South poles, the moon stays above the horizon for about 24 hours a day for 2 weeks each lunar month, which is about 27.3 days. During the long polar nights, zooplankton in the Arctic use the moon's light to help them survive when the sun is gone for months. How the moon looks to us depends on where we are on Earth. If you're in the northern hemisphere, the moon appears upside down compared to how it looks from the southern hemisphere. Sometimes, especially in the tropics, the crescent moon looks like a smile in the sky with its horns pointing upward. This is called a wet moon. The distance between the Earth and moon is not always the same. It changes from about 356,400 kilometers, about 221,500 miles, at its closest, called perigee, to about 406,700 kilometers, about 252,700 miles, at its farthest, called apogee. This changing distance makes the moon look slightly bigger or smaller in the sky by as much as 14%. On average, the moon appears to be about half a degree wide, which is just about the same size as the sun in the sky. That's why we can have perfect solar eclipses. Finally, there's a strange effect called the moon illusion. When the moon is near the horizon, it looks much bigger than when it's high in the sky. But this is just a trick of the mind, a psychological effect, not a physical one. Because the moon is tidally locked, it always shows the same side to us on Earth. The side we see is called the near side, and the other side is the far side. Even though we can't see the far side from Earth, it gets just as much sunlight as the near side. During the new moon phase, the near side is dark, while the far side is fully lit. Long ago, the moon used to spin much faster on its axis, but in its early history, something changed. Because of the strong gravitational pull from Earth, the moon's spinning slowly began to slow down. This happened because of friction caused by the way Earth's gravity pulled and stretched the moon. Over time, the moon lost its spinning energy, turning that energy into heat. Eventually, the moon's rotation matched its orbit around Earth so perfectly that the same side of the moon always faces us. This special state is called being tidally locked. In the years 1998 and 1999, NASA's Lunar Prospector mission collected data from the moon. Then, in the year 2016, scientists studying that data found 2 areas rich in hydrogen, which likely means there was once frozen water, or ice, there. These 2 icy spots were on opposite sides of the moon. Some scientists think these may have been the moon's ancient poles, back when it was still spinning more freely before it got tidally locked to Earth billions of years ago. Although the moon is always half lit by sunlight, except during a lunar eclipse, Earth also plays a role in lighting up the moon. Sunlight reflects off Earth and gently lights up the moon's darker parts. When this reflected light bounces back to Earth from the moon, we can sometimes see it as a soft glow called Earthlight. The moon has a slight tilt, just over 1.5 degrees, compared to the path Earth takes around the sun, called the ecliptic. Because of this tilt, during each draconic year, which lasts around 347 days, the sun appears to slowly shift above and below the moon's equator. This movement is similar to how, on Earth, the sun travels between the Tropic of Cancer and the Tropic of Capricorn throughout the year. This tilting means that the moon's poles spend half the draconic year in darkness or dim light, and the other half in sunlight. However, near the moon's equator, these seasons don't have much of an effect. As the moon orbits Earth, different parts of it are lit up by the sun, creating the familiar phases of the moon we see from Earth. These phases, such as crescent, half, gibbous, and full, happen because of how much of the lit-up side of the moon is visible to us. The amount of light we see depends on the angle between the moon, the sun, and our view from Earth. The moon's brightness and apparent size also change because its path around Earth is not a perfect circle, it's more like an oval. When the moon is closest to Earth, a point called perigee, it can be up to 14% closer and appear up to 30% larger and brighter than when it is farthest away, a point called apogee. When a full or new moon happens during perigee, we call it a supermoon, and it looks impressively big and bright in the sky. In the past, some people thought the surface of the moon was changing over time. Today, scientists believe that most of these claims were just illusions, caused by changes in lighting, blurry observations, or inaccurate drawings. However, small bursts of gas, called outgassing, still happen from time to time and might be behind a few of these strange sightings. Interestingly, scientists now think that a small area of the moon, about 2 miles across, may have been changed by a gas release about 1 million years ago. The moon doesn't reflect much light. Its surface is only a bit shinier than old, worn-out asphalt. Yet, it shines as the second brightest object in our sky after the sun. This brightness comes from something called the opposition surge, a sudden jump in brightness when the moon is directly opposite the sun from our viewpoint. At quarter moon, the moon appears only about 1/10 as bright as it does during a full moon, not half as bright as one might expect. Also, our eyes and brain adjust the way we see the moon. Because the sky is much darker, the moon looks even brighter than it really is. The moon's surface reflects light in a special way. Its soil tends to reflect light back in the direction it came from, making the edges of the full moon look just as bright as the middle. The actual color of the moon is a brownish gray, but this can change depending on the kind of light hitting it and the surface features. Sometimes, the moon can look red or even blue. During a lunar eclipse, Earth's atmosphere bends the sun's red light onto the moon, giving it a reddish color. That's why some people call it a blood moon. The moon can also appear red when it is low in the sky, because we are seeing it through a thicker layer of Earth's atmosphere. The moon may look blue in very rare cases, usually after volcanic eruptions or big fires. That's because certain particles in the air can scatter light in a way that makes the moon appear bluish. When this happens, it's called a blue moon. But it's important to know that the terms red moon and blue moon can also be used to describe special full moons in the calendar, not just their color. Eclipses happen only when the sun, Earth, and moon all line up perfectly, a situation called syzygy. A solar eclipse happens during a new moon, when the moon is directly between Earth and the sun. A lunar eclipse happens during a full moon, when Earth is between the sun and the moon. Even though the sun is about 400 times bigger than the moon, it's also about 400 times farther away. Because of this perfect coincidence, the sun and the moon look almost the same size in our sky. Their slightly changing distances from Earth cause small changes in their apparent size. That's why we sometimes see total solar eclipses, where the moon completely covers the sun, and sometimes annular eclipses, where a ring of the sun remains visible around the moon. During a total eclipse, the bright disk of the sun disappears, and we get to see the sun's outer atmosphere, the glowing corona, shining beautifully in the sky. Over a very long time, the moon is slowly moving farther away from the Earth. Because of this, the moon appears a little bit smaller in the sky as the years go by. At the same time, the sun is gradually growing larger as it moves toward the red giant stage of its life. This means the sun looks slightly bigger in the sky with each passing age. Millions and millions of years ago, the moon looked larger in the sky compared to the sun. So whenever a solar eclipse happened, the moon was big enough to completely block the sun's light. In those times, annular eclipses, where a ring of the sun is still visible around the moon, did not happen at all. But if we look far into the future, millions of years from now, the moon will appear too small to fully cover the sun. When that time comes, Total solar eclipses will no longer be possible. The moon's path around the Earth is not perfectly straight in relation to Earth's path around the sun. It is tilted by a little more than 5 degrees. Because of this tilt, we don't get eclipses every time there's a full moon or a new moon. For an eclipse to take place, the moon must be in just the right spot where its path crosses the Earth's orbit. These special spots are called nodes. Eclipses happen only when the moon is near one of these nodes. There is a pattern to these events. Solar and lunar eclipses follow a repeating cycle called the Saros cycle. This cycle lasts about 18 years, and it helps astronomers predict when eclipses will happen. Now, here's another interesting thing about the moon. It always covers a small circular part of the sky, about half a degree wide. When a bright star or a planet moves behind the moon and disappears from view, it's called an occultation. In fact, a solar eclipse is really just the occultation of the sun. Because the moon is close to Earth, occultations don't look the same everywhere. People in different parts of the world may not see the same stars disappear behind the moon. And because the moon's orbit slowly shifts, different stars get occulted each year. People have been fascinated by the moon for a very long time, thousands and thousands of years. Some of the oldest cave paintings, possibly from as far back as 40,000 years ago, show bulls and geometric shapes that some believe were used to mark time by watching the changing phases of the moon. Even tally sticks that are 20 to 30,000 years old might have been used to count days based on the moon's cycle. In ancient times, the moon was often thought of as a powerful being or god. Early societies created lunar deities, moon gods and goddesses, and later wrote about them using symbols and early writing. One of the oldest known pictures of the moon is carved into a rock called Orthostat 47 in North Ireland. This carving dates back to about 3,000 years before the Common Era. In the 3rd millennium before the Common Era, people worshipped the crescent moon, often linked to the lunar god Nana, also known as Sin. One of the most remarkable figures from that time was Enheduanna, a high priestess, poet, and daughter of the famous king Sargon the Great. She lived around 2,334 to 2,279 years before the Common Era and had the moon carefully observed and tracked from her temple. Around 1800 to 1600 years before the Common Era, a metal disc known as the Nebra sky disk was made in what is now Germany. This disk shows stars like the Pleiades alongside the moon, making it the oldest known drawing of the moon in relation to other stars. By the 5th and 4th centuries before the Common Era, many great thinkers tried to understand the moon better. The Greek philosopher Anaxagoras believed that both the sun and moon were giant rocky spheres, and that the moon simply reflected the sun's light. At the same time, Babylonian astronomers had already figured out the 18-year Saros cycle of lunar eclipses, and Indian astronomers were describing how the moon changed its position every month. In China, an astronomer named Shi Shen gave instructions for how to predict both solar and lunar eclipses. Aristotle, the famous Greek philosopher who lived from 384 to 322 years before the Common Era, thought the moon was the boundary between the ever-changing earthly world and the unchanging heavens. His ideas influenced people for centuries. The brilliant Greek mathematician Archimedes, who lived from 287 to 212 years before the Common Era, even designed a machine, a kind of early planetarium, that could show the movements of the moon and other celestial objects. Around the same time, another Greek thinker, Seleucus, figured out that ocean tides were caused by the pull of the moon and that the tides changed based on where the moon was in relation to the sun. Another scientist, Aristarchus, made one of the first estimates of how far away the moon was. He thought it was about 20 times the Earth's radius, which was a good effort for the time. During the Han Dynasty in China, people believed the moon was made of a special kind of energy called qi. They also understood that the moon's light was just sunlight being reflected. Jing Fang, a Chinese scholar who lived from 78 to 37 years before the Common Era, correctly said that the moon was a sphere. Later, the great astronomer Ptolemy, who lived from 90 to 168 years in the Common Era, made more accurate calculations. He said the moon was about 59 times as far from Earth as the Earth's radius and had a diameter that was a bit more than 1/4 the Earth's diameter. He was surprisingly close to the numbers we know today. Around the 2nd century of the Common Era, the writer Lucian imagined a journey to the moon in his story, A True Story, where travelers met moon inhabitants, possibly the first science fiction tale. In the year 510 of the Common Era, the Indian astronomer Aryabhata wrote that the moon shines because it reflects sunlight. Later, the Islamic scholar Ibn al-Haytham, who lived from 965 to 1039, found that the moon did not reflect light like a mirror. Instead, he said every part of the moon's sunlit surface gives off light in all directions. In China, during the Song dynasty, Shen Kuo, who lived from 1031 to 1095, came up with a creative way to explain the moon's phases. He compared it to a round silver ball covered with white powder. When viewed from the side, it would look like a crescent, just like the moon does in the sky. By the Middle Ages, before telescopes were invented, most people had come to believe that the moon was a round sphere. However, many still thought its surface was smooth and perfect. That all changed in the year 1609, when Galileo Galilei used one of the first telescopes to look closely at the moon. In his book Sidereus Nuncius, he shared drawings showing that the moon had mountains and craters. Interestingly, another man named Thomas Harriot had made similar drawings a few months earlier, but he didn't publish them. After people started using telescopes to look at the moon, scientists in the late 17th century began trying to map and name the features they saw on its surface. Two Italian scientists, Giovanni Battista Riccioli and Francesco Maria Grimaldi, played a big part in this. They created a naming system for lunar features, like craters and plains, that we still use today. In the early 19th century, between the years 1834 and 1836, two German astronomers, Wilhelm Bayer and Johann Heinrich von Mädler, made a much more detailed moon map called the Mappa Selenographica. In 1837, they published a book called Der Mond, the Moon, which was the first study of the moon to use exact measurements, similar to how maps of Earth are made. Their work included the heights of over 1,000 lunar mountains and helped make lunar science much more accurate. When Galileo first looked at the moon through a telescope in the early 17th century, he noticed craters on its surface. For a long time, scientists believed these craters were caused by volcanoes. But in the 1870s, an astronomer named Richard Proctor suggested something different, that these craters were formed by objects crashing into the moon. This idea began to gain support in the year 1892 thanks to the experiments of geologist Grove Carl Gilbert. Later, from the 1920s to the 1940s, more studies comparing Earth's surface to the moon's helped confirm this idea. All this research gave birth to a new field called lunar stratigraphy, the study of the moon's layers and history. By the 1950s, it had become a fast-growing branch of science known as astrogeology. After the end of World War II, new rocket technology was developed. By the late 1950s, both the Soviet Union and the United States had built rockets strong enough to send spacecraft into space. This began the space race as the two superpowers competed to be first in space exploration. Part of this race was focused on reaching the moon. In the year 1957, during the International Geophysical Year, the Soviet Union launched Sputnik 1, the first human-made object to orbit Earth. Then came their lunar program, which was aimed at exploring the moon. After 3 unsuccessful missions in the year 1958, the Soviets succeeded in 1959. Luna 1A was the first spacecraft to escape Earth's gravity and pass close to the moon. Later that same year, Luna 2 became the first human-made object to crash into the moon's surface on purpose. By the end of that year, Luna 3 had traveled around the far side of the Moon, the part we can't see from Earth, and sent back the very first photographs of it. In the year 1966, two more major milestones were reached. Luna 9 became the first spacecraft to land gently on the Moon, and Luna 10 became the first to orbit it, after United States President John F. Kennedy promised in 1961 to land a person on the Moon before the decade was over. NASA, the U.S. space agency, began sending uncrewed missions to study the Moon's surface. These included the Ranger, Lunar Orbiter, and Surveyor programs, which helped scientists learn where and how astronauts could safely land. At the same time, the United States began preparing for crewed missions through the Apollo program. After several test flights, both with and without astronauts, NASA sent Apollo 8 to orbit the Moon in 1968, making it the first human mission to do so. Interestingly, 3 months before that, two tortoises had orbited the Moon aboard the Soviet Zond 5 spacecraft, the first Earth creatures to do so. This was followed by turtles on Zond 6. Then came the big moment. On the 21st of July, 1969, at 2:56 Universal Time, American astronaut Neil Armstrong became the first human to step onto the surface of the Moon. He was the commander of NASA's Apollo 11 mission. This historic moment marked the peak of the space race. An estimated 500 million people around the world watched the landing live on television, the biggest live audience in history at the time. At the same time as Apollo 11, the Soviet Union had their own robotic spacecraft, Luna 15, orbiting the Moon. This was the first time two different missions were exploring the Moon at the same time. From Apollo 11 to Apollo 17, excluding Apollo 13, which had to turn back due to an emergency, astronauts brought back a total of 380 kilograms, or 838 pounds, of moon rocks and soil. They collected 2,196 separate samples. During each landing, they also placed scientific instruments on the Moon's surface. Some of these instruments, like seismometers, which measure moonquakes, heat flow sensors, and magnetometers, which measure magnetic fields, were set up during the Apollo 12, Apollo 14, Apollo 15, Apollo 16, and Apollo 17 missions. Although the live data transmissions from these instruments stopped in late 1977 due to budget cuts, some of the instruments, such as the special mirrors called retroreflectors, are still in use today. These mirrors reflect laser beams sent from Earth, helping scientists measure the exact distance to the Moon. The final crewed Moon mission, Apollo 17, took place in 1972. A year later, in 1973, the United States launched Explorer 49, the last American spacecraft dedicated to the Moon until the 1990s. Meanwhile, the Soviet Union continued sending robotic missions. In 1970, they deployed Luna 17, which carried Lunokhod 1, the first remote-controlled rover ever used on another world. Between 1970 and 1976, 3 Soviet missions, Luna 16, Luna 20, and Luna 24, brought back a total of 300 grams of Moon samples. After the Soviet Union's final Moon mission in 1976, interest in the Moon declined. For the next 14 years, space programs focused more on other planets, like Venus and the outer planets, with missions such as Pioneer 10 in 1972, and also on studying Earth from orbit. This period saw the rise of Earth observation satellites, like the Landsat program in 1972, as well as the development of space stations, such as the Salyut series starting in 1971. The only major Moon-related event during this time was the negotiation of the Moon Treaty in 1979, which was officially ratified in 1984. But it wasn't until 1990 that another Moon mission was launched. That year, Japan sent the Hiton Hagoromo spacecraft to the Moon, marking the first time a country other than the Soviet Union or the United States sent a mission to our closest neighbor in space. In the year 1994, the United States launched a special mission to send a spacecraft called Clementine back to the Moon. This was the first time the US had returned to the moon since the year 1973. The mission was a big success. It gave scientists the first almost complete map of the moon's surface in terms of height and depth. It also captured the first full set of images of the moon using different light wavelengths, revealing many details about its surface. 4 years later, in 1998, another American spacecraft called Lunar Prospector followed. This mission made an exciting discovery. It found signs of extra hydrogen at the moon's poles. Scientists believe this is likely because of water ice hidden beneath the surface, especially inside craters that are always in shadow and never see sunlight. As the new century began, more countries joined the race to explore the moon. Between the years 2004 and 2006, the European Space Agency, ESA, sent its first lunar spacecraft called Smart 1. This mission closely studied the moon's surface and gave us a detailed map of the different chemical elements found there. Then, in the year 2007, China joined the effort with its Chang'e 1 orbiter, which circled the moon until 2009 and created a complete image map of the moon. 1 year later, in 2008, India reached the moon for the very first time with its Chandrayaan-1 spacecraft and its moon impact probe. India became the 5th and 6th country to reach and impact the moon. This mission provided detailed maps showing the moon's chemicals, minerals, and geological features, and importantly, confirmed the presence of water molecules in the lunar soil. On June 18, 2009, the United States sent 2 more spacecraft toward the moon, the Lunar Reconnaissance Orbiter, LRO, and an impactor called L-CROSS. On October 9, 2009, L-CROSS crashed into a crater named Cabeus as planned, sending up a cloud of material for scientists to study. Meanwhile, the LRO is still in orbit around the moon, sending back detailed images and measuring the shape of the moon's surface with great precision. China continued its moon missions in the year 2010 with Chang'e 2, which mapped the moon in even greater detail over 8 months. In 2013, China made another big leap with Chang'e 3, which included both a lander and a rover named Yutu, or Jade Rabbit in English. This was the first time a rover had explored the moon since the Soviet Union's Lunokhod 2 in 1973, and it was also the first soft landing on the moon since Luna 24 in 1976. With this, China became the 3rd country ever to land softly on the moon. In the year 2014, a new kind of mission reached the moon, a private one. The Manfred Memorial Moon Mission was the first probe funded by private sources to successfully get there. In early 2019, China's Chang'e 4 made history by landing on the far side of the moon, something no other country had done before. That same year, India launched Chandrayaan 2, its second moon mission. In 2020, China completed another impressive task. With Chang'e 5, it sent a robotic spacecraft to the moon that collected lunar rocks and soil, bringing back 1,731 grams of material to Earth. Back in 2004, the United States had already started planning to return astronauts to the moon. This led to the creation of the Artemis program. In 2020, a set of international agreements called the Artemis Accords was signed, aiming to guide peaceful and cooperative exploration of the moon. Many countries have since joined. These agreements also helped spark new ideas about how nations should work together on the moon, building on older ideas like the Moon Treaty and ESA's concept for a moon village. In the year 2022, South Korea successfully launched its first moon mission, a spacecraft called Danuri, which lifted off from the United States. Then, in 2023 and 2024, both India and Japan became the 4th and 5th countries to successfully soft-land spacecraft on the moon. Japan's mission, known as the Smart Lander for Investigating Moon, SLIM, made headlines because it managed to survive 3 long and freezing lunar nights. Also in the year 2024, A new milestone was reached when IM-1, the first lander built by a private company, successfully landed on the Moon. In May of that same year, China launched Chang'e 6, which brought back another set of lunar samples, this time from the Moon's far side. This mission also included a Chinese rover that studied the Moon using infrared light. Pakistan joined in by sending its own small lunar orbiter, iCube-Q, along with Chang'e 6. In 2024, 3 more missions headed to the Moon: Nova C-2, iSpace Lander, and Blue Ghost, showing how active and crowded lunar exploration has become. Meanwhile, the Artemis program, along with NASA's Commercial Lunar Payload Services, CLPS, continues to grow. These efforts are working together to send both astronauts and commercial teams to the Moon. The plan includes sending the first woman, the first person of color, and the first non-American astronaut to the lunar surface during the 2020s. At the same time, China is moving forward with its Chang'e program and has announced plans to work with Russia, which is trying to revive its own lunar globe program. Both the US-led and China-led lunar programs have ambitious goals for the future. By the 2030s, each hopes to build a permanent base on the Moon with help from international partners. Before that, the United States and its allies plan to create a space station orbiting the Moon, called the Lunar Gateway. From there, astronauts will travel to the Moon's surface using a landing system called the Human Landing System, where they'll set up temporary camps. Unlike the old Apollo missions, which were mostly about exploration, the Artemis program is focused on building a long-term presence. NASA is teaming up with private companies to build important systems like modern communications networks. In fact, a demonstration of a 4G network is planned to be carried out aboard a Nova C lander in 2024. Another major goal is to use the Moon's natural resources. The US defense agency DARPA is supporting this idea by asking companies to create a 10-year plan for building the foundations of a lunar economy. Even though the Moon has little protection rules compared to other planets, scientists are becoming more concerned about preserving its unique and untouched nature. If telescopes and other astronomy tools are to be placed there, the Moon must be protected from dust, debris, and radio interference caused by human activity. While the Moon doesn't have an atmosphere, landings and crashes still stir up large clouds of dust, which can spread and change its original environment. An expert named Alice Gorman has pointed out that while the Moon might seem lifeless, it still has value that we should respect. She argues that if humans are going to stay there for a long time, we should treat the Moon as a living partner in the journey, not just a lifeless rock. One event that sparked debate was the so-called tardigrade affair in 2019, when the private Israeli spacecraft Bereshit crashed on the Moon while carrying microscopic lifeforms called tardigrades. This raised serious questions about the lack of global rules to protect the Moon from biological contamination. As more missions head to the Moon, space junk, especially debris in lunar orbit, is becoming a growing problem. It could threaten future missions. Managing this lunar waste, especially on the Moon's surface, is now seen as an important challenge that must be addressed in the years ahead. Mars is the 4th planet from the Sun, sitting right after Earth in our solar system. When you look at it through a telescope, you'll notice something striking. Its surface shines with a bright orange-red color. This reddish look comes from a fine layer of dust, made mostly of iron oxide, the same substance that makes rust. That's why people have long called it the Red Planet. Even though Mars is far away, it can often be seen from Earth with the naked eye. It's one of the brightest dots in our night sky. Because of its eye-catching appearance and clear surface features, it's always been a favorite target for people looking through telescopes. Mars is a rocky planet, like Earth, but it's smaller. In fact, it is the 2nd smallest planet in our solar system, with a diameter of about 6,779 kilometers, or around 4,212 miles. A day on Mars, called a sol, lasts about 24.5 hours, which is very close to the length of a day on Earth. but a year on Mars is much longer. It takes Mars almost 687 Earth days to travel once around the Sun, which is nearly 1.9 Earth years. Mars has two tiny moons, named Phobos and Deimos. They don't look like our round moon. Instead, they are small, oddly shaped, and look more like giant potatoes floating in space. The surface of Mars has two very different faces. The northern half is mostly flat and smooth, while the southern half is covered with craters and rugged highlands. This strange split is known as the Martian dichotomy. The planet also boasts some massive natural features, including enormous volcanoes that are no longer active. The biggest one is Olympus Mons, which is a towering 21.9 kilometers tall, that's about 13.6 miles, making it the tallest volcano in the entire solar system. Mars also has one of the largest canyons we know of, Valles Marineris, which stretches for about 4,000 kilometers or 2,500 miles. Even though it may seem like a dead planet, Mars is still geologically active. Scientists have detected Marsquakes shaking the ground below. Swirling dust devils often whip across the surface, and thin wisps of cirrus clouds drift in its sky. The polar ice caps on Mars, as well as its thin atmosphere, contain a large amount of carbon dioxide. The temperature on Mars swings wildly depending on the season. It can get as cold as minus 78.5 degrees Celsius, which is about minus 109.3 degrees Fahrenheit, but on warmer days, it can climb up to around 5.7 degrees Celsius, about 42.3 degrees Fahrenheit. Like Earth, Mars also has seasons. Thanks to its tilted axis, Earth is tilted at 23.5 degrees, while Mars is tilted slightly more at 25 degrees. Mars was born around 4.5 billion years ago. In its earliest days, during a time known as the Noachian period, from about 4.5 to 3.5 billion years ago, the planet was bombarded by space rocks, and massive valleys and river channels were formed. Some scientists even believe that Mars once had oceans. After that came the Hesperian period, from around 3.5 to between 3.3 and 2.9 billion years ago. During this time, huge volcanic eruptions and massive floods carved out giant channels in the land. The most recent chapter in Mars's history is called the Amazonian period, which continues to this day. In this period, winds have become the main force shaping the Martian landscape. Because of its long and dramatic history, scientists are very interested in whether Mars may have once supported life or if it still might today. Starting in the late 20th century, humans began sending robotic spacecraft to explore Mars. The first one to get close was Mariner 4 in the year 1965. Then, in 1971, Mars 2 became the first spacecraft to orbit the planet. 5 years later, in 1976, Viking 1 became the first to land on its surface. As of the year 2023, there are at least 11 active spacecraft orbiting or exploring Mars from the ground. Mars is seen as a top candidate for future human exploration. Even though no human missions are planned for the 2020s, scientists and engineers are working hard to make that dream a reality someday. Scientists believe that Mars formed from the leftover dust and rocks swirling around the young sun. During a wild and chaotic process known as runaway accretion, Mars slowly gathered enough material to become a planet. Because of its position in the solar system, Mars ended up with some unique chemical ingredients. Elements that turn into gas at relatively low temperatures, like chlorine, phosphorus, and sulfur, are more common on Mars than on Earth. Experts think the young sun's powerful solar wind may have blown these lighter elements outward, where they became part of Mars. After the planets were formed, the inner part of the solar system likely went through a violent time known as the Late Heavy Bombardment. During this period, massive rocks from space rained down on planets and moons. Around 60% of Mars's surface still shows signs of those ancient impacts. Some areas are covered in gigantic basins formed when the planet was struck by enormous objects. However, some scientists now question whether the late heavy bombardment really happened as we once thought. There is also evidence that a huge crater, much bigger than any other we know, lies in Mars's northern hemisphere. This massive basin is about 10,600 kilometers long and 8,500 kilometers wide. That's roughly 4 times larger than the enormous South Pole Aitken Basin on the Moon. If proven, it would be the largest impact basin ever discovered. Researchers think it was created when a planet-sized object, possibly as big as Pluto, slammed into Mars around 4 billion years ago. This massive collision may have created the smoother northern plains and caused the stark difference between the northern and southern parts of the planet. A recent study from the year 2023 found clues that Mars may have once had a ring system like Saturn. By studying the orbit of Deimos, one of Mars's tiny moons, scientists believe that billions of years ago, somewhere between 3.5 and 4 billion years ago, Mars had a moon that was 20 times more massive than Phobos. This large moon may have broken apart and formed a ring, with Phobos being the last leftover piece of it. Mars, the red planet, has a long and fascinating geological history. Scientists have divided it into several time periods, but the 3 main ones are known as the Noachian, Hesperian, and Amazonian periods. The Noachian period. This was the earliest chapter in Mars's history, taking place between 4.5 billion and 3.5 billion years ago. During this time, the planet's oldest surface features were formed. These ancient landscapes are full of giant craters caused by asteroid impacts. One major feature believed to have formed during this period is the Tharsis Bulge, a massive volcanic area that rises high above the Martian surface. Near the end of this period, it's thought that huge floods of liquid water carved deep valleys and channels across the land. This period gets its name from a region called Noachis Terra, the Hesperian period. The Hesperian period came next, lasting from around 3.5 billion to somewhere between 3.3 and 2.9 billion years ago. During this time, large amounts of lava flowed across the Martian surface, creating wide plains of solidified rock. These lava fields show that Mars was still very active beneath its crust. The period is named after Hesperia Planum, a broad plain located in the southern part of the planet. The Amazonian period. This is the most recent period and began around 3.3 to 2.9 billion years ago. It continues to the present day. The surface from this time has fewer impact craters, which means fewer objects have hit it in recent history. This suggests that Mars became a quieter place geologically. However, it was not completely inactive. Olympus Mons, the tallest volcano in the solar system, was formed during this time, along with other lava flows across the planet. The name of this period comes from Amazonis Planitia, a flat plain on Mars. Even today, Mars still shows signs of geological activity. In the region called Athabasca Valles, large, flat lava flows were created about 200 million years ago. In another area called the Cerberus Fossae, water appears to have flowed through cracks in the ground less than 20 million years ago, an incredibly recent event in planetary terms. These signs of activity suggest that volcanic forces are still shaping the Martian surface. Also, spacecraft like the Mars Reconnaissance Orbiter have even photographed avalanches happening on the planet. Mars is only about half the diameter of Earth, and its surface area is slightly smaller than all of Earth's dry land combined. It's also less dense than Earth, with about 15% of Earth's volume and only 11% of its mass. This makes gravity on Mars about 38% of Earth's, which means you'd weigh much less there. Mars is often called a desert planet because its rocky, dusty surface looks like Earth's deserts. Its reddish-orange color comes from iron oxide, or rust, which covers much of the ground. But Mars isn't just one color. It can also appear golden, brown, tan, or even greenish, depending on what minerals are in the soil. Sometimes it even looks like butterscotch. Like Earth, Mars is made up of different layers. At the very top is the crust, which is a rocky shell that varies in thickness. On average, it is between 42 and 56 kilometers thick, but in some places it can be as thin as 6 kilometers, like in Isidis Planitia, or as thick as 117 kilometers, such as in the southern Tharsis Plateau. Earth's crust, for comparison, is usually around 27 kilometers thick. The crust of Mars contains many common elements like silicon, oxygen, iron, magnesium, aluminum, calcium, and potassium. Mars is also seismically active, which means it experiences Marsquakes, like earthquakes but on Mars. In the year 2019, NASA's InSight lander recorded over 450 such tremors. Beneath the crust lies the mantle, made of silicate rock. This layer is responsible for many of Mars's volcanoes and other surface features. The upper mantle has a region where seismic waves slow down, and this low-velocity zone stretches to about 250 kilometers deep. The mantle becomes softer and more flexible further down. Interestingly, Mars doesn't have a thick insulating layer like Earth does. Below about 1,050 kilometers, the mantle changes and becomes more like Earth's transition zone. At the very base of the mantle, there is a layer of molten silicate rock that is about 150 to 180 kilometers thick. At the center of the planet is its core, made mostly of iron and nickel. Unlike Earth, which has a solid inner core, Mars's core is completely molten. It takes up about half the radius of the planet, roughly between 1,650 and 1,675 kilometers in size. The core also contains lighter elements like sulfur, oxygen, carbon, and hydrogen. Its temperature is estimated to be between 2,000 and 2,400 kelvins, much cooler than Earth's inner core, which reaches up to 6,200 kelvins. The Martian surface is mainly made of a volcanic rock called tholeiitic basalt, but some areas are richer in silica, making them similar to Earth's andesitic rocks or even silica glass. Certain dark regions suggest the presence of plagioclase feldspar, and some northern areas show signs of sheet silicates and high silicon glass. In the southern highlands, scientists have also detected calcium-rich pyroxenes. Other minerals like hematite and olivine appear in specific locations, and much of the ground is covered by very fine iron oxide dust, which gives Mars its signature color. When NASA's Phoenix lander analyzed Martian soil, it found that the soil was slightly alkaline, with a pH of around 7.7. It also contained important nutrients like magnesium, sodium, potassium, and chlorine, the same nutrients that help plants grow on Earth. However, the soil also had about 0.6% perchlorate, a chemical that is toxic to humans. Mars has many dark streaks on its steep slopes, especially around craters, troughs, and valleys. These streaks often appear suddenly and can grow to be hundreds of meters long. They start out dark and slowly fade as they age. They seem to flow around rocks and other obstacles. One idea is that these streaks reveal darker soil underneath after bright dust slides away. Others think dust devils, water, or even microscopic life might be involved, but scientists are still investigating. Radiation is a big concern for anyone who might travel to Mars. On the surface, the average radiation level is about 0.64 millisieverts per day. That's lower than what astronauts would get on the journey to and from Mars, which is about 1.84 millisieverts per day. For comparison, astronauts aboard space stations orbiting Earth experience around 0.5 millisieverts daily. The lowest radiation levels on Mars are found in Hellas Planitia, where levels can drop to about 0.342 millisieverts per day. Even lower levels, comparable to airline flights on Earth, might exist inside lava tubes near Hadriacus Mons, where radiation could be as low as 0.064 millisieverts per day. Although Mars does not have a strong global magnetic field today, scientists have found signs that parts of the planet's crust are magnetized. This means that a long time ago, Mars may have had a magnetic field that flipped directions over and over, just like Earth's magnetic field does. These ancient magnetic patterns, locked into certain minerals in the rocks, are similar to what we see on the ocean floor of Earth, where magnetic stripes reveal the movement of the planet's crust over time. One theory, first suggested in the year 1999 and revisited in October of 2005 with help from the Mars Global Surveyor spacecraft, is that these magnetic stripes might be proof that Mars once had plate tectonics, where huge pieces of the crust slowly move around. This may have happened about 4 billion years ago, before Mars's internal dynamo, the engine that creates magnetic fields, stopped working, causing the planet's magnetic field to fade away. Long before spacecraft ever visited Mars, two early astronomers, Johann Heinrich von Maedler and Wilhelm Beer, became the first dedicated mapmakers of the Red Planet. Though they are better remembered for their maps of the Moon, they were pioneers in studying Mars. They were the first to realize that most of the dark and light areas on Mars stayed in the same place over time, meaning these were real features, not just shadows or illusions. They also worked out a much more accurate measurement of how long a day on Mars lasts. In the year 1840, after 10 years of careful observations, Maedler drew the very first map of Mars. The names of features on Mars come from many different sources. For example, the darker and lighter patches of the surface, which are visible from Earth, are called albedo features, and these are often named after places and characters from ancient mythology. Craters that are larger than about 50 kilometers across are named after scientists, writers, and others who contributed to the study of Mars, so long as they are no longer living. Smaller craters are named after towns and villages from all over the world, as long as the population is under 100,000 people. Big valleys are named using words that mean Mars or star in many different languages, while smaller valleys are often named after rivers on Earth. Some of the older names for Mars's surface features are still used today, though they have been updated as we've learned more. For instance, what was once called Nix Olympica, meaning the snows of Olympus, is now known as Olympus Mons, or Mount Olympus, the tallest volcano on Mars. From Earth, the surface of Mars looks like it's divided into lighter and darker regions. The pale areas, which are full of reddish dust rich in iron, were once thought to be continents, so they were given names like Arabia Terra, land of Arabia, and Amazonis Planitia, Amazonian plain. The darker spots were once thought to be oceans or seas, and so they were named accordingly, like Mare Erythraeum, Mare Serenum, and Aurorae Sinus. The biggest of these dark areas is Syrtis Major Planum, which is visible even with a telescope from Earth. The permanent ice caps on Mars also have names. The one at the North Pole is called Planum Boreum, while the one at the South Pole is known as Planum Australe. Just like Earth has a prime meridian that starts at Greenwich, Mars needed a starting point for its system of longitudes. Maedler and Beer picked a spot in the year 1830 to use as a reference when making their early maps. Later on, in the year 1972, the Mariner 9 spacecraft sent back thousands of detailed images of Mars. Using these, scientists Merton E. Davies, Harold Masursky, and Gérard de Vaucouleurs picked a small crater called Airy Zero, located in a region named Sinus Meridiani, which means Meridian Bay, to mark 0 degrees longitude on modern Mars maps. Unlike Earth, Mars does not have oceans, so it has no natural sea level. To create a standard way to measure height on Mars, scientists had to define a 0 level. This reference point is called the areoid, similar to Earth's geoid. On Mars, this 0 elevation is defined as the height where the air pressure is 610.5 pascals. That's the same pressure at which water can exist as a solid, liquid, and gas at the same time, a special condition called the triple point. This pressure is only about 0.6% of Earth's sea level pressure. To organize all of Mars's geography, the United States Geological Survey divided the planet into 30 different map sections called cartographic quadrangles. Each of these areas is named after one of the classical dark or light surface features. In April of the year 2023, the New York Times reported that a new and more complete global map of Mars had been created using pictures from the HOPE spacecraft. A few days later, on the 16th of April, NASA released an even more detailed map based on their own images. One of the most dramatic places on Mars is the Tharsis region, a vast highland area that contains several gigantic volcanoes. The most famous of these is Olympus Mons, a shield volcano that is more than 600 kilometers, or about 370 miles, wide. Because of its enormous size and the complex slopes around it, it's hard to measure its height exactly. From its base to its peak, Olympus Mons rises more than 21 kilometers, about 13 miles, more than twice as high as Mauna Kea in Hawaii, when measured from the ocean floor. If you measure from the surrounding plains of Amazonis Planitia, which lie over 1,000 kilometers, or 620 miles away, the mountain climbs a total of 26 kilometers, or 16 miles. That's nearly 3 times as high as Mount Everest on Earth. Because of this, Olympus Mons is considered the tallest, or possibly second tallest mountain in the entire solar system. The only mountain that might be taller is Rhea Silvia Peak, found on the asteroid Vesta, which could be between 20 and 25 kilometers, about 12 to 16 miles high. The surface of Mars is divided into 2 very different types of terrain. In the north, the land is flatter and seems to have been smoothed by ancient lava flows. In the south, the landscape is much rougher and filled with craters from long-ago impacts. Scientists believe that around 4 billion years ago, a huge object may have slammed into the northern hemisphere of Mars. If so, the object could have been as small as 1/10 or as large as 2/3 the size of Earth's moon. This massive collision might have created a giant impact basin measuring about 10,600 by 8,500 kilometers, or 6,600 by 5,300 miles. That would make it even larger than Utopia Planitia, or the enormous South Pole Aitken Basin on the Moon, possibly making it the biggest known impact crater in the solar system, big enough to cover an area similar in size to Europe, Asia, and Australia all combined. Mars is a planet marked by thousands of scars left by space rocks that crashed into its surface over billions of years. Scientists have counted more than 43,000 impact craters that are at least 5 kilometers wide. One of the most striking of these is Hellas, a gigantic crater that stretches across 2,300 kilometers and drops down as deep as 7,000 meters. It's so big and bright that it can be seen from Earth without a telescope. Other major impact sites include the Argyre Basin, which is about 1,800 kilometers across, and the Isidis Basin, measuring around 1,500 kilometers wide. Because Mars is smaller and lighter than Earth, the chance of it being hit by an object from space is only about half as high. However, since Mars orbits closer to the asteroid belt, the busy region between Mars and Jupiter, it actually gets hit by space debris more often than Earth does. Mars is also more likely to be struck by comets with shorter orbits, especially those that stay inside Jupiter's path. Some Martian craters show signs that the ground became wet after a meteorite impact, suggesting that water may have been present underground at the time. One of the most dramatic features on Mars is a huge canyon system called Valles Marineris, which means mariner valleys in Latin. Long ago, it was also known by the name Agatha Demon on ancient maps that imagined Martian canals. This canyon stretches for about 4,000 kilometers in length and drops as deep as 7 kilometers in places. To give you an idea of its size, Valles Marineris is about as long as the whole continent of Europe and covers about 1/5 of the planet's circumference. By comparison, Earth's famous Grand Canyon is only 446 kilometers long and nearly 2 kilometers deep. Scientists believe that this enormous canyon was created when the land around the Tharsis region swelled up, causing the surface to crack and collapse. In the year 2012, some researchers suggested that Valles Marineris might not just be a deep crack, but actually a boundary where two large pieces of Mars's crust may have moved past each other, kind of like tectonic plates on Earth. If that's true, then Mars might have a form of plate tectonics, even if it's very different from Earth's. Space probes have also discovered something mysterious on Mars: possible caves. A spacecraft called Mars Odyssey, using its thermal camera, called Themis, spotted 7 dark holes on the side of the volcano Asia Mons. These openings are thought to be entrances to caves and were given the nickname the Seven Sisters after people the scientists cared about. The entrances range in width from about 100 meters to 252 meters. Their depth is estimated to be between 73 and 96 meters, though they could go much deeper underground. Only one of the caves, called Dina, has a visible floor, which is 130 meters deep. These caves might offer protection from the harsh surface environment, shielding against tiny meteors, solar flares, ultraviolet radiation, and harmful cosmic particles. Mars once had a magnetic shield, like Earth's, but it lost this protection about 4 billion years ago. This may have happened due to many large asteroid impacts. Without that magnetic field, the solar wind, a stream of particles from the Sun, hits Mars's atmosphere directly and blows it away bit by bit. Satellites like Mars Global Surveyor and Mars Express have spotted trails of gases drifting off into space, and NASA's MAVEN spacecraft is still studying this atmospheric loss today. Compared to Earth, the air on Mars is extremely thin. In fact, the air pressure on Mars is less than 1% of what we feel at sea level on Earth. In places like Olympus Mons, the pressure is as low as 30 pascals, while in deep valleys like Hellas Planifia, it can go up to about 1,155 pascals. On average, it's around 600 pascals. That's similar to the air pressure found 35 kilometers above Earth's surface, far higher than most planes fly. Mars's weak gravity, only about 38% of Earth's, allows the atmosphere to stretch out higher. The atmospheric scale height, which is how far you need to go up before the pressure drops significantly, is about 10.8 kilometers on Mars, compared to just 6 kilometers on Earth. The Martian atmosphere is made up mostly of carbon dioxide, about 96%. There's also nearly 2% argon, almost 2% nitrogen, and only small traces of oxygen and water vapor. It's also filled with fine dust particles, about 1.5 micrometers across. These tiny particles give the sky on Mars a reddish-brown or tawny color when viewed from the surface. Sometimes the sky even appears pink because of the iron-rich dust floating in the air. Scientists have detected small amounts of methane gas in the Martian atmosphere. The levels of methane change with the seasons, ranging from about 0.24 parts per billion in the northern winter to around 0.65 parts per billion in the summer. Since methane doesn't last long in the atmosphere, anywhere from a little more than half a year to 4 years, there must be something constantly making it. Most scientists think it's caused by natural chemical reactions between rocks, water, and carbon dioxide, especially involving a mineral called olivine. But some researchers wonder if it could also be a sign of microbial life. Sound behaves differently on Mars, too. Because of the thin air and the high amount of carbon dioxide, sound travels more slowly and fades away faster. Data from NASA's Perseverance rover shows that low-pitched sounds travel at about 240 meters per second, while higher-pitched sounds go a bit faster, about 250 meters per second. Mars also has auroras, like the northern and southern lights on Earth, but they appear all over the planet, not just at the poles. This is because Mars no longer has a global magnetic field to concentrate these lights in certain areas. In September of the year 2017, a huge solar storm hit Mars and created an aurora 25 times brighter than anything seen before. During this event, radiation levels on the surface of Mars temporarily doubled, reminding scientists just how harsh and unpredictable space weather can be on the red planet. Mars has seasons just like Earth does. These seasons switch between the northern and southern halves of the planet. But unlike Earth, Mars has a very stretched out orbit around the Sun. This means that Mars gets much closer to the Sun at one point in its orbit and much farther away at another. When Mars is closest to the Sun, a point called perihelion, it's summer in the southern hemisphere and winter in the northern one. And when Mars is farthest from the Sun, known as aphelion, it's winter in the southern hemisphere and summer in the north. Because of this uneven orbit, the seasons in the southern half of Mars are much more extreme than in the northern half. Southern summers can be much hotter, and southern winters can be much colder. In fact, the southern summer temperatures can be as much as 30 degrees Celsius or 54 degrees Fahrenheit warmer than the summer temperatures in the north. Temperatures on Mars vary a lot. On a warm summer day near the equator, it can reach up to 35 degrees Celsius, 95 degrees Fahrenheit. But during the night, or in the colder parts of the planet, it can drop as low as minus 110 degrees Celsius, minus 166 degrees Fahrenheit. That's a huge difference. This happens because the Martian atmosphere is extremely thin. It's only about 1% as thick as Earth's. It can't hold heat very well, and the soil on Mars also cools down quickly after sunset. Mars is about 1.5 times farther from the Sun than Earth is. Because of this, it only gets about 43% of the sunlight that we receive. That's not much, and it adds to the chilly environment. One fascinating thing about Mars is its gigantic dust storms. These are the biggest dust storms in the entire solar system. They can blow at speeds over 100 kilometers per hour, around 60 miles per hour, and sometimes they cover just small areas. But other times they grow so large that they engulf the whole planet. These huge storms usually happen when Mars is closest to the Sun and can even cause the planet's overall temperature to rise. Mars does have a lot of water, but most of it is frozen as ice and buried under layers of dust, especially at the poles. The southern polar ice cap alone holds so much frozen water that, if it melted, it could cover almost the entire planet in a layer of water about 11 meters, or 36 feet, deep. Liquid water, however, can't survive on the surface of Mars for long. The air pressure is simply too low, less than 1% of Earth's pressure. Only in the lowest areas on Mars, where both pressure and temperature might be just high enough, could water possibly exist in liquid form for short periods of time. There is a small amount of water vapor in the Martian atmosphere, not enough to make it rain like on Earth, but enough to create clouds made of ice crystals. Mars also experiences snowfall, sometimes made of water ice and sometimes of dry ice, which is frozen carbon dioxide. Looking at Mars's surface, scientists have found strong evidence that liquid water once flowed across the planet. Huge channels, long, wide paths cut into the ground, can be seen in about 25 different places. These channels seem to have been formed when massive amounts of water suddenly burst out from underground, flooding the surface. Some scientists think glaciers or even flowing lava might have helped shape them too. One of the most impressive of these features is Ma'adim Vallis, a vast canyon that stretches for 700 kilometers, about 430 miles. It's 20 kilometers, or 12 miles wide, and 2 kilometers, or 1.2 miles, deep in some areas, even bigger than the Grand Canyon on Earth. Experts believe this canyon was carved out by flowing water a long time ago. Even more recently, perhaps just a few million years ago, some of these channels may have formed, showing that Mars might have had flowing water in its more recent past as well. In the oldest regions of Mars, scientists have also discovered smaller, branch-like networks of valleys spread across the land. These resemble the way rivers and streams branch out on Earth, and they likely formed from rainfall in Mars's early days. Some valleys may have also been shaped by underground water slowly rising to the surface, but the main cause seems to be rainwater runoff. Along the walls of craters and deep canyons, there are thousands of features that look like gullies, small valleys similar to those found in deserts on Earth. These are mostly found in the southern highlands and tend to face the Martian equator. All of them are located more than 30 degrees from the planet's poles. Many scientists believe these gullies were formed by liquid water from melting ice, though others think dry processes, like the movement of carbon dioxide frost or loose dust, might be responsible. The fact that no old or weathered gullies have been found and there are no impact craters overlapping them suggests these features are very young and might even still be changing today. Other signs of a wetter past on Mars include deltas and alluvial fans, landforms that are created when flowing water slows down and drops the sediment it was carrying. These features are often found inside craters and suggest that there were once crater lakes on Mars. This is backed up by studies of Mars's minerals, sediment layers, and land shapes. More evidence comes from the discovery of certain minerals that only form in the presence of water. For example, two minerals called hematite and goethite have been found on Mars, and both usually form when water is around. In the year 2004, the Mars rover Opportunity discovered a mineral called jarosite, which only forms in acidic water. This proved that liquid water was once present on Mars. Later, in the year 2007, another rover named Spirit found large deposits of silica, which also form in wet conditions. Then, in December of 2011, Opportunity found gypsum on the Martian surface, another mineral that forms in water. Scientists believe that even deep below the surface of Mars, inside the planet's mantle, there could be a lot of water locked away in the form of hydroxyl, a molecule made of oxygen and hydrogen. There may be as much water inside Mars as there is inside Earth. In fact, if this hidden water were brought to the surface and spread out, it could cover the entire planet in a layer between 200 and 1,000 meters deep. That's between 660 and 3,280 feet. On the 18th of March, 2013, NASA shared some fascinating news. Their Curiosity rover had found signs of water in rock samples on Mars. More specifically, it discovered minerals that had interacted with water in the past, most likely a type of hydrated calcium sulfate. These minerals were found in pieces of rocks that scientists nicknamed Tintina and Sutton Inlier, as well as in tiny veins and round formations called nodules in other rocks, like Knorr and Wernicke. One of Curiosity's scientific tools, called the DAN instrument, helped detect water hidden below the surface. It revealed that the soil contained as much as 4% water down to a depth of about 60 centimeters. This discovery happened while the rover was traveling from its landing spot, known as Bradbury Landing, to an area called Yellowknife Bay, part of a region named Glenelg. Then, in September of 2015, NASA made another exciting announcement. They found strong evidence of salty water, also called brine, flowing down certain slopes during the warmer Martian summer months. These dark streaks, known as recurring slope lineae, appear when the temperature rises above minus 23 degrees Celsius. But when it gets colder, the brine freezes. At first, scientists believed these streaks were formed by liquid water trickling just below the surface. However, later studies suggested that the streaks might actually be dry, sandy flows, with only a small amount of water involved, if any at all. So, scientists still don't have a final answer about how much liquid water exists, or used to exist, on Mars. There's also a theory that the vast northern plains of Mars were once covered by a deep ocean, possibly hundreds of meters deep. While this idea is still debated, in March of 2015, some scientists proposed that this ancient Martian ocean may have been about the same size as Earth's Arctic Ocean. They based this on the amount of deuterium, a heavy form of hydrogen, found in the Martian atmosphere. On Mars, deuterium is 5 to 7 times more abundant than on Earth. That suggests that Mars had much more water in the distant past. Earlier, Curiosity had also found signs of deuterium in a region called Gale Crater. However, those levels weren't quite high enough to confirm the presence of a full-sized ocean. Some researchers also remind us that, so far, climate models of ancient Mars have not shown it being warm enough to support large bodies of liquid water. One of the most remarkable discoveries near the Martian North Pole is a huge crater named Korolev. It measures about 81 kilometers wide and contains around 2,200 cubic kilometers of water ice. That's a massive amount of frozen water. In November of 2016, NASA announced yet another exciting find: a large quantity of underground ice in an area called Utopia Planitia. Scientists estimated that this ice held as much water as Lake Superior on Earth, about 12,100 cubic kilometers. More recently, between the years 2018 and 2021, the European Space Agency's ExoMars Trace Gas Orbiter picked up more signs of water in one of Mars's biggest canyon systems, known as Valles Marineris. The signs point to ice hiding below the surface. Mars orbits the Sun at an average distance of about 230 million kilometers. One complete trip around the Sun, its year, takes about 687 Earth days. A day on Mars, known as a sol, is just a little longer than an Earth day. It lasts 24 hours, 39 minutes, and about 35 seconds. A Martian year is roughly equal to one Earth year, 320 days, and just over 18 hours. Mars has an axial tilt of about 25 degrees, very close to Earth's tilt. Because of this, Mars experiences seasons similar to those on Earth, but they last nearly twice as long since its year is much longer. At this point in time, the North Pole of Mars points toward the bright star Deneb. Mars travels in an orbit that is more stretched out or elliptical than Earth's. In fact, out of all the planets in our solar system, only Mercury has a more eccentric orbit. Interestingly, about 1,350,000 years ago, Mars had a much more circular orbit, more round than Earth's orbit today. Mars's orbit goes through changes, or cycles, that last around 96,000 Earth years. When Mars comes closest to Earth, a moment called opposition, it happens roughly every 780 days. But the exact time between oppositions can vary between 764 and 812 days. Because of the elliptical paths the two planets follow, their closest distance can vary too. At their nearest, Mars and Earth can be about 54 million kilometers apart. At their farthest, they can be as much as 401 million kilometers away. Oppositions that occur when Mars is also near its closest point to the Sun are called perihelic oppositions. These are special moments when Mars appears particularly large and bright in our night sky. This happened in the years 2003, 2018, and will happen again in 2035. The events in 2020 and 2033 will also be quite close to this ideal viewing time. Mars usually appears in the sky with a yellow, orange, or reddish glow. Its average brightness is a bit less than that of Jupiter, but at its peak, it becomes the second brightest planet in the night sky. Only Venus is brighter. When Mars is farthest from Earth, it's over 7 times farther than it is at its closest point. Because of Earth's atmosphere, ground-based telescopes can usually only see Martian features that are about 300 kilometers wide, even during the best viewing times when the two planets are closest. As the planet Mars moves closer to what astronomers call opposition, something fascinating happens in the night sky. For a little over 2 months, about 72 days, Mars begins what's known as retrograde motion. This means it appears to move backward in a loop-like path when seen from Earth, even though it's still moving forward in space. This strange illusion happens because Earth, which orbits the Sun faster than Mars, overtakes it for a while. During the middle of this backward loop, Mars becomes especially bright. Its glow in the sky reaches its peak and is easier to see than usual. Mars also has 2 small moons that orbit very close to it. These moons are much smaller than Earth's moon. The larger one is called Phobos, and it's only about 22 kilometers wide. That's about 14 miles. The smaller one is named Deimos, and it's around 12 kilometers across, or 7.5 miles. Even though they are tiny, these 2 moons have captured the curiosity of scientists for many years. no one is completely sure where Phobos and Deimos came from. One popular idea is that they were once wandering asteroids, and Mars's gravity pulled them in and trapped them in orbit. Both moons were discovered in the year 1877 by an American astronomer named Asaph Hall. He named them after the twin sons of the Greek god of war, Ares. In Greek mythology, Phobos was the spirit of panic and fear, and Deimos represented terror and dread. They would follow their father into battle. Later, the Romans gave the name Mars to their own god of war, and that became the name of the planet. Even today, in modern Greek, Mars is still called Ares. From the surface of Mars, the movements of its moons would look quite different from what we see with Earth's moon. Phobos, the closer of the two, behaves very oddly. It rises in the west and sets in the east, which is the opposite of what we expect, and it does this in just 11 hours. That means someone on Mars could see it rise and set twice in a single day. Deimos, on the other hand, rises in the east like our moon, but it moves very slowly. This is because it's just outside what's known as a synchronous orbit, where a moon would appear to hover in the same spot in the sky. Phobos is slowly being pulled closer to Mars by the planet's gravity. Scientists believe that in about 50 million years, Phobos might either crash into the surface or break apart and form a ring around Mars, just like the rings of Saturn, though much smaller. Scientists have long puzzled over the true origin of Phobos and Deimos. Their dark, rocky surfaces and their chemical makeup are similar to certain types of asteroids known as carbonaceous chondrites. This supports the idea that they were captured asteroids. But there's a problem. Captured objects usually have odd-shaped orbits, and yet both Phobos and Deimos travel in almost perfect circles around Mars's equator. That's strange and hard to explain. Another idea is that they might have formed from dust and rock that came together, a process called accretion, early in Mars's history. But if that's true, their composition should be more like Mars's surface, not like distant asteroids. There's even a third theory. Some scientists think that a giant asteroid may have smashed into Mars long ago, blasting pieces of Mars into space. These fragments could have come back together and formed the moons. In fact, some recent evidence suggests that Phobos has a very porous, sponge-like interior and contains minerals known from Mars. This would support the idea that Phobos formed from Martian debris. Another possibility is that Mars once had a larger moon, which broke apart in a violent impact, leaving behind Phobos and Deimos as fragments. There might even be more tiny moons around Mars that we haven't found yet. These could be less than 100 meters wide. That's about 330 feet. Some scientists also predict there could be a thin ring of dust floating between Phobos and Deimos. Throughout history, Mars has captured the attention of skywatchers and astronomers. Every couple of years, Mars and Earth line up in a way that brings the red planet closest to us, making it much easier to observe. These special moments are called oppositions. Even more remarkable are perihelic oppositions, when Mars is not only opposite the Sun, but also at its closest point to the Sun. This makes it look even bigger and brighter in our sky. Ancient people were fascinated by Mars. The Sumerians, some of the earliest known civilizations, called the planet Nergal, the god of war and disease. At first, Nergal wasn't very important, but later he became the main god in the city of Nineveh. In old Mesopotamian writings, Mars was even described as the star of judgment of the fate of the dead. Egyptian astronomers also observed Mars. By the year 1534 before the Common Era, they had already noticed its unusual retrograde motion. The Babylonians were extremely skilled in tracking planets. By the time of the Neo-Babylonian Empire, they were regularly recording where planets appeared in the sky and were able to predict their paths. They discovered that Mars completes 37 synodic periods, cycles of being opposite the Sun, every 79 years, which means it makes 42 loops through the zodiac. They even created early math techniques to improve their predictions. In ancient Greece, Mars had different names. One of them was Pyroeis, which means fiery one. The more common name was Ares, after the Greek god of war. The Romans later adopted this god into their own mythology and renamed the planet Mars. They also connected the planet with images of battle like swords and shields. The famous Greek philosopher Aristotle, who lived in the 4th century before the Common Era, once noticed that Mars passed behind the Moon. This helped him understand that Mars was farther away than the Moon. Another great thinker, Ptolemy, who lived in Alexandria, tried to explain how Mars moved in the sky. He collected his ideas in a large work known as the Almagest, which became the main astronomy book in Europe and the Middle East for more than 1400 years. Meanwhile, in China, ancient astronomers were also observing Mars. Records show that by the 4th century before the Common Era, Chinese scholars were already writing about the red planet. In traditional East Asian beliefs, Mars was called the fire star, which fits its bright red appearance and was based on an ancient system of 5 elements called wuxing. Back in the 17th century, a brilliant astronomer named Tycho Brahe made careful measurements of Mars as it moved across the sky. He focused on something called the diurnal parallax, which is how much a planet appears to shift position when seen from different places on Earth. This was an important step in figuring out how far Mars is from our planet. Another great astronomer, Johannes Kepler, used Brahe's measurements to make some early calculations about the distance to Mars. But Kepler did much more than that. As he studied Mars, he made a surprising discovery. Mars does not move around the Sun in a perfect circle. Instead, its path is shaped like a stretched-out circle called an ellipse. He also noticed that Mars speeds up as it gets closer to the Sun and slows down as it moves farther away. This behavior would later be explained by the laws of physics, especially the conservation of angular momentum, the same principle that makes a spinning ice skater spin faster when they pull their arms in. When telescopes became available, astronomers could measure Mars's parallax more accurately. In the year 1672, an Italian-French astronomer named Giovanni Domenico Cassini was the first to do this using a telescope. However, the tools of that time were still not very precise, and the early measurements were quite rough. A rare event happened on the 13th of October in the year 1590. Mars passed behind Venus in the sky, an event called an occultation. It was seen by Michael Meislin in the city of Heidelberg, and it is the only time in recorded history that such an event was observed. A few years later, in 1610, the famous Italian scientist Galileo Galilei became the first person to look at Mars through a telescope. In the following years, the Dutch astronomer Christian Huygens became the first person to draw a map of Mars that showed actual surface features. As time went on and telescope technology improved, people could see Mars more clearly. By the 19th century, telescopes had become good enough to show distinct details on the planet's surface. On the 5th of September, in the year 1877, Mars was in a special position called a perihelic opposition, which meant it was especially close to Earth and very bright in the sky. Taking advantage of this moment, an Italian astronomer named Giovanni Schiaparelli used a 22-centimeter telescope in Milan to create the most detailed map of Mars ever seen at the time. He saw and drew long, straight lines on the surface of the planet and called them canali, which in Italian means channels or grooves. However, when this word was translated into English, it was misunderstood as canals, which led many to think they were artificial waterways built by intelligent beings. These mysterious lines sparked wild imagination. Inspired by these maps, a wealthy scholar named Percival Lowell built his own observatory in the United States. It was equipped with telescopes measuring 30 and 45 centimeters across. Lowell spent many years observing Mars, especially during a good viewing opportunity in 1894. He wrote several books suggesting that Mars was home to an advanced civilization, and his ideas fascinated the public. Other astronomers also reported seeing the canali, including Henri-Joseph Perrotin and Louis Tolon. who used one of the largest telescopes in the world at that time in the city of Nice, France. People were amazed. Could Mars really have canals and even oceans or forests? The idea of Martian life became very popular. However, as even bigger and better telescopes were used, the famous straight lines became harder to find. In the year 1909, the astronomer Eugene Antoniadi used an enormous 84-centimeter telescope and saw no canals at all, only irregular patterns and patches. In the 20th and 21st centuries, humanity took a giant leap by sending robotic spacecraft to explore Mars up close. Dozens of these unmanned machines, orbiters, landers, and rovers were launched by countries such as the Soviet Union, the United States, European nations, India, the United Arab Emirates, and China. These missions studied Mars's surface, weather, and geology in great detail. The first spacecraft to visit Mars was NASA's Mariner 4. It launched on the 28th of November in the year 1964 and flew past the planet on the 15th of July in the year 1965. Mariner 4 took the first close-up pictures of another planet and even detected a weak radiation belt around Mars, only about 0.1% as strong as Earth's. The Mariner missions in the 1960s and 70s completely changed how scientists thought about Mars. The earlier ideas about oceans and life were largely discarded. The Viking missions, especially their experiments to detect life, led most scientists to believe that Mars was a barren and lifeless world. In later years, NASA's Mars Global Surveyor, launched in 1996 and active until 2006, made extremely detailed maps of the planet's surface, magnetic fields, and mineral composition. Today, you can view these maps online, even on platforms like Google Mars. Exploration continued with spacecraft like Mars, Reconnaissance Orbiter, and Mars Express. NASA now offers online tools such as Mars Trek, which shows stunning views of the planet using 50 years of data, and Experience Curiosity, a 3D simulator that lets users explore Mars through the eyes of the Curiosity rover. By the year 2023, Mars had 10 active spacecraft exploring it. 8 of them were orbiting the planet: 2001 Mars Odyssey, Mars Express, Mars Reconnaissance Orbiter, MARVN, ExoMars Trace Gas Orbiter, the Hope Orbiter from the United Arab Emirates, and China's Tianwen-1 orbiter. 2 rovers, Curiosity and Perseverance, were traveling across the surface, studying rocks, soil, and signs of past life. NASA's Escapade mission is expected to launch in the year 2025. The European-built Rosalind Franklin rover, designed to search for ancient life, was originally supposed to launch in 2018, but has been delayed several times. As of now, it is scheduled to launch no earlier than the year 2028. The project received new funding and restarted in the year 2024. NASA and the European Space Agency are also working on a joint mission to bring samples back from Mars, possibly launching in the year 2026. China's ambitious Tianwen-3 mission, which also aims to return samples, is set for the year 2030. As of February 2024, more than 7 tons of debris from past Mars missions, including crashed spacecraft and discarded parts, are scattered across the planet. In April of the year 2024, NASA selected several companies to begin exploring the possibility of offering commercial services to support robotic scientific missions on Mars. The main focus of these studies includes setting up telecommunications, delivering payloads, and capturing images of the Martian surface. Back in the late 19th century, many scientists believed that Mars could support life, including having oxygen and water. However, in 1894, W. Campbell, working at the Lick Observatory, observed Mars and concluded that if water vapor or oxygen existed in the atmosphere of Mars, it would be in amounts too small to detect with the instruments available at that time. This finding went against many other measurements made by scientists at the time and was not widely accepted. Campbell, along with V.M. Slipher, repeated the study in 1909 using better instruments, but still reached the same conclusion. It wasn't until W.S. Adams confirmed these findings in 1925 that the idea of Mars being similar to Earth and potentially habitable was finally dismissed. Despite this, in the 1960s, articles were still published speculating about the possibility of life on Mars, ignoring explanations other than life for the planet's seasonal changes. Today, our understanding of what makes a planet suitable for life focuses on whether it has liquid water on its surface. Typically, this requires a planet's orbit to fall within what is known as the habitable zone, a region around a star where conditions are right for liquid water to exist. For our Sun, this zone is believed to stretch from the orbit of Earth to just beyond Mars. During its closest approach to the Sun, called perihelion, Mars moves inside this zone, but its thin atmosphere, which has very low pressure, prevents water from staying in a liquid form over large areas for long periods of time. Despite this, evidence from the past suggests that water did flow on Mars at one point, indicating that the planet may have been more hospitable in the past. However, recent findings suggest that any water that once existed on Mars was likely too salty and acidic to support life as we know it. Mars's environment makes it very difficult for life to survive. The planet's surface doesn't transfer heat well. Its lack of a protective magnetosphere leaves it vulnerable to the solar wind, and its thin atmosphere isn't able to keep water in liquid form, so water tends to turn into gas. Additionally, Mars is almost, if not completely, geologically inactive, meaning that volcanic activity has ceased, and there is no longer a process that recycles chemicals and minerals between the planet's surface and interior. Evidence suggests that Mars may have been more capable of supporting life in the past, but we still don't know if life ever existed there. In the mid-1970s, NASA's Viking probes carried out experiments to search for microorganisms in the soil of Mars at their landing sites. The experiments showed signs of life, such as a temporary increase in carbon dioxide production when the soil was exposed to water and nutrients. However, these results were later disputed, and the debate about whether the Viking missions found evidence of life continues, with NASA scientist Gilbert Levin standing by the idea that life may have been discovered. In 2014, a study of Martian meteorite EETA 7901 revealed that it contained high concentrations of chlorate, perchlorate, and nitrate ions. These chemicals could potentially be widespread on Mars and might indicate that if any organic molecules exist there, they would have to be buried deep beneath the surface to survive the harsh conditions. Mars orbiters have also detected small amounts of methane and formaldehyde, which could point to life. These compounds would typically break down quickly in Mars's atmosphere, so their presence is intriguing. However, they could also be produced by volcanic or other geological processes, such as reactions with certain types of rock. In addition, scientists have found impact glass on Mars, glass formed when meteors strike the planet's surface. On Earth, this type of glass can sometimes preserve signs of life, so it's possible that the glass on Mars might contain similar evidence if life ever existed there. In June of the year 2024, a rock discovered on Mars, called the Chayava Falls rock, was designated by NASA as a potential biosignature. The Perseverance rover collected a sample of the rock, which may eventually be returned to Earth for further study. While this discovery is fascinating, scientists are still unable to say for sure whether the rock has a biological or non-biological origin, as the data available is not yet conclusive. Throughout the 20th and 21st centuries, various plans have been proposed for human missions to Mars, but none have been fully realized. The NASA Authorization Act of 2017 instructed NASA to study the possibility of sending humans to Mars in the early 2030s, but a later report concluded that this goal was not yet feasible. In 2021, China announced plans to send a crewed mission to Mars in the year 2033. Private companies, such as SpaceX, have also proposed plans for human missions to Mars, with the long-term goal of establishing a permanent human presence on the planet. As of 2024, SpaceX is working on developing its Starship launch vehicle with the goal of making Mars colonization possible. Elon Musk, the founder of SpaceX, envisions that within the next 20 years, a Mars colony will begin to take shape. This will be made possible by mass-producing starships and initially relying on supplies from Earth, as well as utilizing local resources on Mars until the colony becomes self-sustaining. Any future mission to Mars will likely take place during the optimal launch window, which occurs every 26 months. There has even been a proposal to build a space elevator on the moon Phobos, one of Mars' moons. In addition to national space agencies and private companies, organizations like the Mars Society and the Planetary Society are also advocating for human missions to Mars. Proxima Centauri is the closest star to Earth after our own Sun. It is located about 4 1/4 light-years away from us in the southern sky, in a group of stars called the constellation Centaurus. This star was first discovered in the year 1915 by an astronomer named Robert Innes. Proxima Centauri is a very small and dim star. It is so faint that you cannot see it without a telescope. In terms of brightness, its apparent magnitude is 11.13, which means it's far too dim to be seen with the naked eye. Its name comes from Latin and means the nearest of Centaurus. This little star is part of a bigger group of stars known as the Alpha Centauri star system. Proxima is also called Alpha Centauri c. It lies about 2.18 degrees southwest of the main pair of stars in that system, Alpha Centauri A and Alpha Centauri B. Right now, Proxima is about 12,950 astronomical units away from that pair. That's about 1/5 of a light-year, and it takes around 550,000 years to go all the way around them. Proxima Centauri is known as a red dwarf. It has only about 12.5% of the Sun's mass, but its density is much higher, around 33 times greater than the Sun's. Because Proxima Centauri is so close to Earth, scientists have been able to measure its size quite accurately. Its diameter is about 1/7 that of the Sun, or roughly 14%. Although it doesn't shine very brightly most of the time, Proxima Centauri is a flare star. This means that, from time to time, it suddenly gets much brighter due to strong bursts of magnetic energy. These outbursts, or flares, happen when magnetic activity deep inside the star becomes intense. These flares can even produce X-rays similar in strength to those coming from our Sun. Inside Proxima Centauri, energy moves from the core to the surface through a process called convection, where hot material rises and cooler material sinks. This mixing helps the star use almost all of its hydrogen fuel efficiently. Because of its slow energy production, it will keep burning for an incredibly long time, around 4 trillion years. So far, scientists have found 1 confirmed planet orbiting Proxima Centauri and 2 more that might be real. The confirmed one is called Proxima Centauri b. It moves around the star at a distance of about 7.5 million kilometers, or 0.05 astronomical units, and it completes 1 orbit in a little over 11 Earth days. It is slightly heavier than Earth, about 1.07 times the Earth's mass. Proxima b lies in what's called the habitable zone of the star, where temperatures might be just right for liquid water. But because Proxima Centauri is a red dwarf that sends out powerful flares, it's not clear whether life could actually survive there. Another possible planet, called Proxima Centauri c, is much farther out, about 220 million kilometers, or 1.5 astronomical units from the star. It takes around 5.2 Earth years to complete 1 orbit. The third one, a smaller possible planet called Proxima Centauri d, is very close to the star, only about 4.3 million kilometers away, and it goes around it every 5.1 days. Proxima Centauri belongs to a category of stars on a chart called the Hertzsprung-Russell diagram. Its specific type is called M5.5, which means it is a cool, low-mass star with a color leaning toward red-yellow. Its surface temperature is around 3,000 degrees Kelvin. If we were to look at Proxima Centauri from a distance of 33 light-years, which equals 10 parsecs, it would look extremely dim, with an absolute visual magnitude of 15.5. Its total brightness across all types of light is just 0.16% of the Sun's, and in the visible range, what human eyes can see, it's only 0.0056% as bright. Most of its energy, more than 85%, is given off as infrared light, which is invisible to us. In the year 2002, scientists used a special technique called optical interferometry with the Very Large Telescope to find that Proxima Centauri's apparent size in the sky is about 1.02 milliarc seconds. Knowing its distance, they calculated its actual size to be about 1/7 of the Sun's diameter, or about 1.5 times the size of Jupiter. Its mass is estimated to be about 12.2% of the Sun's, or the same as 129 Jupiters. Another method, based on watching how it bends light from other stars, microlensing, suggested its mass might be around 15% of the Sun's, though with less accuracy. Small stars like Proxima Centauri are much denser than larger ones. Its average density is around 47.1 grams per cubic centimeter, compared to the Sun's 1.4 grams per cubic centimeter. Its surface gravity is also much stronger, about 162 times stronger than the gravity we feel on Earth. In 1998, scientists studying Proxima's brightness changes thought it rotates once every 83.5 days. Later studies in the early 2000s suggested it might actually take closer to 116.5 days. More precise measurements found it rotates roughly every 90 days. Because it's a low-mass star, its entire inside is stirred by convection. This is different from the Sun, where only the outer layers move this way. In Proxima Centauri, this churning helps keep the star stable and spreads out the leftover helium from fusion. That means, unlike the Sun, which will only use up about 10% of its hydrogen before changing, Proxima Centauri will burn nearly all its fuel before it leaves the main sequence phase of its life. The movement of hot plasma inside the star helps create strong magnetic fields. These fields sometimes release energy in sudden flares. These flares can last as little as 10 seconds and make the star much brighter during that time. One of the most powerful flares ever seen from Proxima Centauri happened on May 6, 2019. It gave off an incredible amount of ultraviolet light, around 2 × 10 to the power of 30 ergs. That's extremely energetic, enough to heat up the area to 27 million degrees Kelvin, which is hot enough to produce X-rays. When the star is quiet, its X-ray brightness is around 4 to 16 × 10 to the power of 26 ergs per second, similar to the Sun's. But during the strongest flares, it can reach up to 10 to the power of 28 ergs per second. Proxima Centauri has a very active outer layer called the chromosphere. This activity can be clearly seen in the star's light spectrum, especially in a bright line created by magnesium atoms that have lost one electron. This special glow happens at a wavelength of 280 nanometers, far shorter than what human eyes can see. Scientists believe that nearly 88% of Proxima Centauri's surface may be actively flaring or glowing, which is a much higher percentage than the Sun shows, even when it's at the most active part of its 11-year cycle. Even when Proxima Centauri seems calm and isn't shooting off many flares, the constant magnetic activity keeps its corona, the hot outermost layer, at an incredible temperature of around 3.5 million Kelvin. For comparison, the Sun's corona is usually about 2 million Kelvin. Despite its smaller size, Proxima Centauri gives off about as much X-ray energy as the Sun. Now, among red dwarf stars like Proxima Centauri, this level of activity is actually considered on the low side. That matches with what scientists estimate to be the star's age, about 4,850,000,000 years. Over time, red dwarfs spin more slowly, and their activity gradually fades over billions of years. Interestingly, Proxima Centauri's activity doesn't stay the same. It seems to follow a repeating pattern that lasts around 442 days. That's much shorter than the Sun's solar cycle, which lasts about 11 years. Proxima Centauri also gives off a stellar wind, but it's fairly weak, losing no more than 20% as much mass as the Sun does through its own solar wind. However, because Proxima is much smaller, it actually loses more material from each square meter of its surface, up to 8 times as much as the Sun. This tiny red star still has a very long life ahead. Because it burns fuel very slowly, Proxima Centauri is expected to remain in its current state, known as the main sequence, for about 4 trillion years. As time goes on, it will convert more of its hydrogen into helium. This will cause it to shrink a bit and grow hotter, eventually becoming a type of star called a blue dwarf. Toward the end of its life, it will shine brighter, up to 2.5% of the Sun's brightness, and could warm up any nearby planets for several billion years. Once it runs out of hydrogen, Proxima won't turn into a red giant like the Sun will. Instead, it will quietly evolve into a helium-white dwarf and slowly cool off over time. There are different ideas about how Proxima Centauri became part of the Alpha Centauri star system. One idea is that long ago, when all these stars were still forming in a cluster, Proxima, a small, low-mass star, was pulled in by the stronger gravity of the 2 larger stars, Alpha Centauri A and B. But to be sure of this theory, scientists still need more precise measurements of how Proxima is moving. If Proxima Centauri was part of the Alpha Centauri system from the very beginning, it would likely share the same chemical ingredients. Proxima's gravity might also have shaken up the planet-forming disks around Alpha Centauri A and B, possibly helping to bring water and other materials to rocky inner planets. Another possibility is that Proxima Centauri was captured later during a close encounter with the system. In that case, its orbit would have started off wild and stretched out, but over time it would have been stabilized by the pull of the Milky Way and nearby stars. If this theory is true, it might mean Proxima's planets have been less disturbed by Alpha Centauri's gravity. As Alpha Centauri A and B grow older and lose some of their mass, Proxima Centauri is expected to drift away from them. This separation might happen in about 3.5 billion years. According to data from a space observatory called Gaia, released in the year 2020, Proxima Centauri is about 4.2465 light-years away from the Sun. That's roughly 268,550 times the distance from the Earth to the Sun. Other measurements from earlier years have given nearly the same results, using different instruments such as the Hubble Space Telescope and the Hipparcos satellite. When viewed from Earth, Proxima Centauri appears to be a little more than 2 degrees away from Alpha Centauri in the sky, about 4 times wider than the full moon appears to us. It also moves across the sky fairly quickly, shifting by about 3.85 arc-seconds each year. It's also moving toward us at a speed of about 22.2 kilometers per second. If you could stand on a planet near Proxima Centauri and look up at the sky, you'd see our Sun as a bright star in the constellation Cassiopeia. It would shine with a brightness similar to stars like Achernar or Procyon from our point of view on Earth. Proxima Centauri has held the title of closest star to the Sun for about 32,000 years, and will keep that title for around 25,000 more. After that, Alpha Centauri A and B will take turns being the closest stars to us, swapping places every 79.91 years. According to predictions made in the early 2000s, Proxima Centauri will come its absolute closest to the Sun in about 26,700 years. At that time, it will be just over 3 light-years away. This small star travels around the center of our galaxy, the Milky Way, at a distance that changes between 27,000 and 31,000 light-years. Its orbit is a little oval-shaped, with a gentle wobble of about 0.07. Proxima Centauri was first thought to be connected to Alpha Centauri A and B when it was discovered in the year 1915. That's why it's sometimes called Alpha Centauri C. Observations from the Hipparcos satellite and ground telescopes supported the idea that all three stars are tied together by gravity. In 2017, scientists used precise measurements to confirm that Proxima really does orbit the Alpha Centauri pair. Proxima's orbit is very long and stretched out. It takes about 547,000 years to complete one full circle around Alpha Centauri A and B. During this orbit, it can get as close as about 4,300 astronomical units, AU, and as far as about 13,000 AU. Right now, Proxima is nearly at the farthest point in its orbit, around 12,947 AU from the other two stars, which equals about 1.94 trillion kilometers. There are other stars that seem to move through space in the same direction and at similar speeds as the Alpha Centauri group. These include 6 individual stars, 2 pairs of stars, and 1 triple star system. Because they're all moving in the same general way, scientists think they may have formed together in the same star cluster long ago. As of the year 2022, astronomers have found 3 planets orbiting Proxima Centauri. One of them is confirmed, and 2 others are still being studied. One of the possible planets might be one of the smallest ever found using the wobble technique. Another, called Proxima b, is very close in size to Earth and orbits within the star's habitable zone, where temperatures could allow for liquid water. The third, called Proxima c, might be a gas dwarf, located much farther out, but there is still some debate about whether it truly exists. The search for planets around Proxima Centauri, the closest known star to our Sun, actually began way back in the late 1970s. Astronomers were curious to know if this small red star might have any hidden worlds orbiting it. In the 1990s, scientists used a technique called radial velocity, which looks for tiny wobbles in a star's motion caused by the pull of a planet, to study Proxima Centauri. These early studies helped limit the size of any planet that might be hiding there. But there was a problem. Proxima Centauri is a very active star, and it flares often. These flares add noise to the measurements, making it difficult to tell if the wobbles were caused by a planet or just the star itself. In 1998, researchers used the Hubble Space Telescope's Faint Object Spectrograph to take a closer look at Proxima Centauri. They thought they might have seen signs of a planet orbiting about half an astronomical unit, which is the average distance between Earth and the Sun from the star. However, follow-up observations using another camera on Hubble, the Wide Field and Planetary Camera 2, did not find any planets. Other studies done using astrometry, a technique that tracks a star's position very precisely, at the Cerro Tololo Inter-American Observatory, ruled out the possibility of a Jupiter-sized planet orbiting the star with a period between 2 and 12 years. Fast forward to 2017, when a team of astronomers, using the Atacama Large Millimeter Array, also known as ALMA, announced something new. They had discovered a belt of cold dust circling Proxima Centauri, located between 1 and 4 astronomical units from the star. This dust was incredibly cold, around 40 Kelvin, which is much colder than any place on Earth, and had a mass roughly 1% that of our planet. The astronomers also spotted 2 more interesting features. A second, even colder dust belt at around 30 astronomical units, and a mysterious object giving off light about 1.2 arcseconds from the star. There was even a hint of a warmer dust belt close to the star at about 0.4 astronomical units. But after digging deeper into the data, the scientists realized that most of the strange signals were probably caused by a huge flare from the star that happened in March 2017. In the end, they concluded that the presence of dust near the star wasn't necessary to explain what they had seen. Then came the discovery that truly grabbed the world's attention: Proxima Centauri b. This planet, also known as Alpha Centauri CB, orbits its star at a distance of about 0.05 astronomical units, which is roughly 7.5 million kilometers, much closer than Mercury is to the Sun. It completes one full orbit in just over 11 Earth days. Its mass is estimated to be at least 1.07 times that of Earth. Even more exciting is the fact that its temperature might be just right for liquid water to exist, meaning it could lie within the habitable zone of Proxima Centauri, the region around a star where life as we know it might be possible. Hints of this planet were first found in 2013 by Mikko Tuomi from the University of Hertfordshire, who was analyzing old observation data. To verify the finding, a group of astronomers launched a special project called Pale Red Dot in January 2016. On August 24, 2016, a team of 31 scientists from around the globe, led by Guillaume Anglada Escudé of Queen Mary University of London, officially confirmed the planet's existence. Their findings were published in the scientific journal Nature. They used two powerful instruments to make their observations: HARPS on the European Southern Observatory's 3.6-meter telescope at La Silla Observatory, and UVES on the 8-meter Very Large Telescope at Paranal Observatory. Many scientists have tried to catch this planet passing directly in front of its star, a phenomenon called a transit, but success has been limited. On September 8, 2016, a telescope at Zhongshan Station in Antarctica picked up a signal that looked like a possible transit, but the evidence was not strong enough to be conclusive. In the same 2016 study that confirmed Proxima Centauri b, scientists also found another strange signal, this one lasting between 60 and 500 days. But they couldn't say for sure whether it came from a second planet or just the star's own unpredictable behavior. Then came news of a second possible planet, Proxima Centauri c. This one is much farther out, orbiting at around 1.5 astronomical units, or about 220 million kilometers away, and taking about 1,900 days, or 5.2 years, to complete one orbit. It is believed to be either a super-Earth or a small gas giant with a mass about 7 times that of Earth. If Proxima Centauri b is like Earth, Proxima Centauri c would be more like Neptune. But because it's so far from its star, its surface is extremely cold, around 39 Kelvin, and it is unlikely to be habitable. The first report of this second planet came in April 2019 from Mario Damaso and his team, who noticed subtle shifts in the star's movements in data from HARPS. In 2020, more evidence came from Hubble Space Telescope data gathered back in 1995. A possible image of the planet was captured in infrared light using a telescope called Sphere, but the image wasn't clear. If that blurry object really is Proxima Centauri c, it may be brighter than expected, which could mean it has a ring system, much like Saturn, with rings stretching out to about 5 times the radius of Jupiter. However, in 2022, a group led by Etienne Artigot questioned whether this planet was truly confirmed. In 2019, while reviewing data from the new espresso spectrograph, scientists tried to refine their measurements of Proxima Centauri b. In the process, they found yet another curious signal, this one with a repeating cycle of 5.15 days. If it turns out to be a planet, it would be a small one, about 0.29 times the mass of Earth. After more analysis, the existence of this signal was confirmed, and in February 2022, a new candidate planet was announced. Even before any of these discoveries, the idea of a life-sustaining planet around Proxima Centauri was explored in science documentaries like Alien Worlds. The show suggested that a habitable planet could exist in the star's habitable zone, which lies between 0.023 and 0.054 astronomical units from the star. A planet in this range would orbit very quickly, with a year lasting only 3.6 to 14 days. However, such a planet would likely be tidally locked, meaning the same side would always face the star, resulting in one side stuck in endless daylight and the other in perpetual night. But if the planet had a thick enough atmosphere, it might still be able to move heat around the planet, allowing for more stable conditions. One major concern is that Proxima Centauri has frequent stellar flares, which could strip away a planet's atmosphere. But scientists like Gibor Basri from the University of California, Berkeley, believe this might not be a deal-breaker. If the planet had a strong magnetic field, it could protect itself from these harmful particles. Even a slow-spinning, tidally locked planet could generate a magnetic field if its inside stayed molten and active. Still, not everyone agrees that life could survive around red dwarf stars like Proxima Centauri. Scientists who support the rare Earth hypothesis argue that such stars create harsh conditions. For instance, strong coronal mass ejections from the star could gradually blow away a planet's atmosphere, especially if the planet has a weak magnetic field. In December 2020, a strange radio signal called BLC-1 was picked up and thought to possibly come from Proxima Centauri. For a moment, the world wondered, could it be a sign of intelligent life? Sadly, it turned out to be nothing more than radio interference caused by humans on Earth. Back in the year 1915, a Scottish astronomer named Robert Innes made an exciting discovery. He was working as the director of the Union Observatory in Johannesburg, South Africa, when he found a star that appeared to move through space in the same way as Alpha Centauri, one of the closest stars to Earth. Innes suggested this new star be called Proxima Centauri, which means the nearest of Centaurus, though the proper Latin name would be Proxima Centaurus. 2 years later, in 1917, a Dutch astronomer named Joan Voet, working at the Royal Observatory at the Cape of Good Hope, measured how far away this new star was using a method called trigonometric parallax. He found that Proxima Centauri was roughly the same distance from the Sun as Alpha Centauri, an exciting confirmation that this really was a nearby neighbor. At the time, Proxima Centauri was the faintest star ever discovered. In 1928, an American astronomer named Harold L. Alden made an even more precise measurement and confirmed that Proxima Centauri was indeed the closest star to our solar system. His measurements showed that Proxima Centauri was just a tiny bit closer to us than Alpha Centauri. A few years earlier, in 1925, a Canadian astronomer named John Stanley Plaskett estimated the size of Proxima Centauri using a technique called interferometry. He found it to be about 207,000 miles wide, which is roughly 0.24 times the diameter of our Sun. Then, in 1951, another major discovery was made by American astronomer Harlow Shapley. He announced that Proxima Centauri is what's known as a flare star. That means it occasionally bursts out with sudden increases in brightness. By examining older photos of the star, astronomers noticed that it flared up in about 8% of the pictures. At the time, it was the most active flare star ever recorded. Because Proxima Centauri is so close to Earth, astronomers have been able to study these flares in great detail. In 1980, a space telescope called the Einstein Observatory captured an X-ray energy burst from one of its flares. Over the years, other space telescopes, such as EXOSAT, ROSAT, and ASCA from Japan in 1995, also observed these energetic outbursts. More recently, powerful X-ray telescopes like XMM Newton and Chandra have continued to keep a close eye on this tiny but fiery star. Because Proxima Centauri is located deep in the southern sky, it can only be seen from places south of 27 degrees north latitude. It is also a red dwarf, which means it is very dim and cannot be seen with the naked eye. In fact, even if you were standing on one of the nearby stars in the Alpha Centauri system, Proxima would still only appear as a faint fifth magnitude star. From Earth, its brightness is so low, at magnitude 11, that you would need a telescope with a lens at least 3 inches wide to see it, even under perfect viewing conditions. In August of 2016, the International Astronomical Union, the group that officially names stars, decided to formally recognize the name Proxima Centauri and added it to their list of approved star names. That same year, something extraordinary happened. Astronomers witnessed a superflare from Proxima Centauri, the most powerful one ever recorded. The star's brightness suddenly increased by 68 times, rising to magnitude 6.8. Scientists believe that flares like this probably happen around 5 times a year, but they are so short, only lasting a few minutes, that they are extremely difficult to catch. On April 22nd and 23rd of the year 2020, the New Horizons spacecraft, which had traveled far beyond Pluto, took photos of Proxima Centauri and another nearby star, Wolf 359. When these images were compared to photos taken from Earth, a large shift in the star's positions could be seen, a phenomenon called parallax. Although this showed just how far New Horizons had traveled, it didn't improve the accuracy of previous distance measurements to the stars. Because Proxima Centauri is the closest known star to Earth, many scientists have suggested it as a possible destination for future interstellar space missions. However, if we rely only on current, non-nuclear propulsion technologies, it would take an incredibly long time, thousands of years, to get there. For example, the Voyager 1 spacecraft, which is now moving at about 17 kilometers per second, or around 38,000 miles per hour, would need about 73,775 years to reach Proxima Centauri, and that's only if it were headed in that direction and the star itself wasn't moving. But scientists have imagined faster ways to travel between the stars. Using nuclear pulse propulsion, a concept that involves propelling a spacecraft with tiny nuclear explosions, a journey to Proxima Centauri might be possible in just about 100 years. This idea has inspired ambitious projects like Project Orion, Project Daedalus, and Project Longshot. One of the most exciting modern ideas is called Breakthrough Starshot, which aims to send tiny space probes to the Alpha Centauri system in the first half of the 21st century. These probes would travel at 20% the speed of light, pushed by an array of powerful Earth-based lasers totaling 100 gigawatts. If everything works as planned, the probes could fly past Proxima Centauri about 20 years after launch, or even go into orbit after about 140 years, depending on how they navigate the star system. Once there, these mini-spacecraft would take pictures and gather information about the star's planets and their atmospheres. The data they collect would take about 4.25 years to travel back to Earth. The International Space Station, often called the ISS, is the biggest space station ever built by humans. It orbits high above the Earth in what's called low Earth orbit and was created through a teamwork effort by 5 major space agencies: NASA from the United States, Roscosmos from Russia, ESA from Europe, JAXA from Japan, and CSA from Canada. These agencies, along with their many partners and contractors, have worked together for years to build, maintain, and operate this incredible laboratory in space. The main purpose of the ISS is to be a place where scientists can do experiments in microgravity, that is, in the very weak gravity found in space. This allows them to study how things behave without the pull of Earth's gravity affecting the results. It also helps researchers understand how living in space affects the human body and other life forms. The station itself is divided into 2 main parts. One is called the Russian Orbital Segment, or ROS for short, which was developed by Russia's space agency, Roscosmos. The other is known as the United States Orbital Segment, or USOS, and it was built by the United States, Europe, Japan, and Canada. One of the most eye-catching features of the station is its massive integrated truss structure, a kind of giant framework that holds the station's large solar panels and radiators and connects them to the main modules. These modules are like different rooms or compartments that serve a wide range of purposes, conducting science experiments, living quarters for the crew, storage, controls for the spacecraft, and even airlocks that allow astronauts to go on spacewalks. The ISS has a total of 8 docking ports where visiting spacecraft can connect. It travels around our planet at an average height of about 400 kilometers or 250 miles above Earth's surface. The station makes one full orbit around the Earth in about 93 minutes, which means it completes more than 15 full laps around the planet every single day. The idea behind the ISS came from 2 earlier space station projects: the United States' planned Space Station Freedom and Russia's Mir 2 project. These 2 plans were eventually merged to form one bigger, more ambitious project. The first part of the ISS was launched into space in the year 1998. Major parts of the station were sent up using powerful Russian rockets like the Proton and Soyuz, as well as NASA's Space Shuttle. The first long-term crew, known as Expedition 1, arrived at the station on the 2nd of November in the year 2000. Since that day, humans have lived on the ISS continuously, making it the longest human presence in space, over 24 years and 164 days by March of the year 2024. By that time, 279 people from 22 different countries had visited the station. Looking ahead, the ISS is expected to continue operating until the end of the year 2030. At least one new module is planned to be added, a special unit called the Payload Power Thermal Module, built by a private company named Axiom Space. After 2030, the station will be safely deorbited with the help of a spacecraft from NASA. The dream of international cooperation in space began to grow back in the early 1970s as the intense space race between the United States and the Soviet Union started to cool down. In the year 1975, the 2 nations carried out their first joint mission, called the Apollo-Soyuz Test Project. This historic mission marked the first time spacecraft from 2 rival nations docked together in space. It was seen as a great success and led to discussions about more shared missions in the future. One idea, called International Skylab, suggested launching a backup Skylab space station for visits by both American Apollo and Russian Soyuz spacecraft. Another bold plan, the Skylab Salyut Space Laboratory, aimed to connect Skylab with a Soviet Salyut station. Sadly, many of these ideas were abandoned in the late 1970s due to budget cuts and the return of Cold War tensions. Even a plan to have the new space shuttle dock with a Salyut station was eventually shelved. During the early 1980s, NASA began planning a brand new modular space station called Freedom. It was intended to be America's answer to the Soviet Salyut and Mir stations. In 1984, Europe's space agency, ESA, was invited to join the Freedom Project, and by 1987 they had approved their own contribution, a science laboratory called Columbus. Japan also joined the effort. In response to a request from NASA in 1982, Japan proposed a scientific laboratory of its own, which was officially announced in 1985. It became known as the Japanese Experiment Module, or KIBO, which means hope in Japanese. In early 1985, science ministers from ESA's member countries approved the Columbus program. Led by Germany and Italy, this plan was the most ambitious space project ever undertaken by the European agency. It aimed to build a module that could eventually become a full European space station by the end of the century. However, as costs grew in the early 1990s, Congress in the United States became concerned about the rising price tag of the Freedom Station. Lawmakers insisted that NASA bring in more international partners to share the financial burden, or the entire project might be cancelled. At the same time, the Soviet Union was working on its own new space station, Mir 2. Some of its modules were already being built by the mid-1980s. But after the Soviet Union collapsed in 1991, Russia no longer had the money to finish the project on its own. Both countries were now struggling to move forward with their space station plans. So, in a historic move, American and Russian officials decided to combine their efforts. In September of the year 1993, United States Vice President Al Gore and Russian Prime Minister Viktor Chernomyrdin announced the plan to build a single, joint space station. This would eventually become the International Space Station. As a preparation step, they also agreed to work together on a series of missions involving the Mir station, in what became known as the Shuttle Mir program. When the ISS was first imagined, it was meant to be much more than just a lab in space. It was supposed to be an observatory, a place for manufacturing things in space, and a kind of stopover base for future missions to the Moon, Mars, or even asteroids. Not all of these big ideas have come true, but over the years, new roles have been added. In the 2010 United States National Space Policy, the ISS was also given roles in supporting commercial space projects, building international relationships, and providing educational opportunities. The ISS is a perfect place to do science because it provides electricity, internet data, temperature control, and human support, all needed to carry out complicated experiments. Some smaller spacecraft without people on board can also do experiments in space, but the ISS has a big advantage. Scientists can work on their experiments over a long time and even make changes along the way. If new tools or equipment are needed, they can be sent up on the next supply mission. On board, astronauts carry out research in many different fields. These include astrobiology, astronomy, the physical sciences, studying new materials, space weather, weather forecasting, and human health, especially how our bodies respond to long periods in space. Scientists on Earth can receive the data quickly and suggest changes, making the research even more productive. Every few months, a new team of astronauts arrives, and each crew usually spends several months living and working in space. Together, a team of 6 people can provide around 160 hours of work each week. However, a good portion of that time is spent just keeping the station running, doing maintenance, repairs, and daily tasks. One of the most fascinating and important experiments aboard the International Space Station, or ISS, is the Alpha Magnetic Spectrometer, known as the AMS. This powerful scientific instrument was sent into space to help scientists solve some of the biggest mysteries of the universe, including the search for dark matter, a strange, invisible substance that seems to make up a large part of the universe but has never been directly seen. According to NASA, the AMS is just as important as the famous Hubble Space Telescope. Right now, the AMS is attached to the ISS. It could not have been launched on a regular satellite because it needs a lot of electricity and has to send back a large amount of data. On the 3rd of April in the year 2013, scientists announced that they may have seen signs of dark matter using the AMS. They found an unexpected number of high-energy particles called positrons in cosmic rays coming toward Earth, and this could be a hint that dark matter is out there. Space is an extremely harsh place for life. Without protection, living things are exposed to powerful radiation made up of high-speed particles from the sun and deep space. There's no air, temperatures can swing from freezing to boiling, and gravity is very weak, almost like floating. However, some very simple life forms called extremophiles and tiny creatures called tardigrades are able to survive in space when they dry out completely, a process called desiccation. Doctors and scientists use the ISS to study how space affects the human body during long trips. This research is very important because living in space for a long time can lead to problems like muscles getting weaker, bones becoming thin and fragile, and body fluids shifting around. These effects could be dangerous for astronauts, especially if they try to land on another planet after a long space journey. For example, in the year 2006, research showed that astronauts might have a high risk of breaking bones or having trouble moving if they land on a planet like Mars after spending 6 months in space. Medical experiments on the ISS are done for the National Space Biomedical Research Institute. One major experiment is called the Advanced Diagnostic Ultrasound in Microgravity Study. In this experiment, astronauts perform ultrasound scans, a way of seeing inside the body while being guided by doctors on Earth. Since there is usually no doctor on board the ISS, this method helps diagnose health problems remotely. This technique could also be useful back on Earth in places where doctors are not easily available, like remote villages or during emergencies. In August of the year 2020, scientists discovered something amazing. Bacteria from Earth, especially a tough kind called Deinococcus radiodurans, survived for 3 years in outer space. These bacteria are extremely resistant to harsh conditions, and this discovery supports the theory of panspermia, the idea that life might travel through space and possibly spread from one planet to another on space dust, meteoroids, or spacecraft. During the decade of the 2010s, research into Earth, stars, and deep space increased a lot on the ISS, especially after the United States finished building its part of the station in the year 2011. Over more than 20 years, scientists aboard the ISS and on Earth have studied the atmosphere, including things like tiny airborne particles called aerosols, ozone, lightning, and chemicals known as oxides. They have also studied the sun, cosmic rays, space dust, antimatter, and dark matter. Some of the special Earth-watching instruments that have been used on the ISS include the Orbiting Carbon Observatory 3, ISS RapidScat, ECO-STRESS, the Global Ecosystem Dynamics Investigation, and the Cloud Aerosol Transport System. For looking into space, scientists have used tools like the Solar Telescope, the Neutron Star Interior Composition Explorer, the Calorimetric Electron Telescope, the Monitor of All-Sky X-ray Image, also called MAXI, and the Alpha Magnetic Spectrometer. Even though gravity on the ISS is about 90% as strong as on Earth, objects inside the station float because they are constantly falling around the Earth in orbit. This creates the feeling of weightlessness, also known as microgravity. However, this weightlessness is not perfect. It is slightly disturbed by several things: air drag from the thin atmosphere, vibrations from equipment and people moving around, the spinning gyroscopes that help control the station's direction, thrusters firing to change position, and the tiny differences in gravity across the station called tidal effects. Scientists are studying how this microgravity affects the growth and development of living things, including plants and animals. NASA also wants to see how it affects the creation of special protein crystals and the growth of three-dimensional human tissues, things that might help with medical research. The behavior of liquids in space is also being closely studied. In microgravity, liquids mix in ways they don't on Earth, so researchers can learn more about how different fluids behave. Some reactions happen more slowly in low gravity and cold temperatures, and this helps scientists better understand things like superconductivity, the ability of materials to carry electricity without resistance. Another big focus of ISS research is materials science, finding ways to make materials stronger, lighter, or more useful. Some of this research may lead to better products or more efficient technologies on Earth. Scientists are also studying how fire behaves in space, which may help improve how we burn fuels, reduce pollution, and use energy more wisely on Earth. The ISS is also a testing ground for future missions to the Moon and Mars. It gives astronauts a chance to practice working with spacecraft in space, learning how to operate, fix, and maintain them while far from Earth. This hands-on experience helps lower the risks of long missions and helps develop the technology and skills needed to explore the solar system. When talking about long missions, it's also important to think about what it's like to be isolated in a small space with the same people for a long time. The European Space Agency, or ESA, has studied this through experiments like Mars 500, which kept a crew on Earth in a simulated space capsule for many months. While the ISS helps us study the effects of weightlessness and radiation, experiments like Mars 500 are better for understanding the psychological effects of isolation. In the year 2011, a top Russian space official suggested that a shorter version of the Mars 500 experiment might even be done on the ISS itself. In the year 2009, Sergei Krasnov, a space expert, pointed out how important it was for countries to work together in space exploration. He explained that when nations join forces and combine their different skills and resources, they can achieve much more than if each one worked alone. He said this teamwork gave us greater confidence in both the success and safety of exploring space. He also praised the International Space Station, or ISS, for helping push forward our efforts to explore the area around Earth and for preparing us to explore even further, like the Moon and Mars. A future mission to send astronauts to Mars will most likely involve countries from around the world, not just those already involved in the ISS. In the year 2010, Jean-Jacques Dordain, who was then the head of the European Space Agency, said he wanted to suggest to the other 4 ISS partners that China, India, and South Korea be invited to join. A year later, in February of 2011, Charles Bolden, who was the head of NASA at the time, said, "Any mission to Mars is likely to be a global effort. However, there's a law in the United States that makes it harder for NASA to work with China. This law says NASA needs approval from both the FBI and the United States Congress before working on space projects with China. The astronauts aboard the ISS do more than just conduct scientific research. They also help inspire and educate students back on Earth. They run experiments designed by students, perform science demonstrations, and even talk to classrooms using radio and email. Students can also recreate ISS experiments in their own classrooms. The European Space Agency offers many free learning resources that teachers can download. In one lesson, students can explore a 3-dimensional digital model of the ISS, both inside and out. They are given surprise challenges to solve in real time, just like astronauts do. In Japan, the space agency JAXA works hard to get kids excited about space and science. Their goal is to inspire young people to take pride in their work and understand how important life and responsibility are. Using educational guides, students learn more about the history and future of human spaceflight and gain a better appreciation of life on Earth. One unique JAXA project is called Seeds in Space. In this experiment, sunflower seeds that spent about 9 months aboard the ISS are grown back on Earth. This helps scientists and students study how space affects the seeds. Between the year 2008 and the middle of 2010, researchers from over a dozen Japanese universities carried out all sorts of experiments in space. Besides science and education, the ISS is also used for cultural activities. Tetsuo Tanaka, a director at JAXA, once said, "There is something about space that touches even people who are not interested in science. This shows how space can move people emotionally and creatively." Another fun and educational program is called Amateur Radio on the ISS, or ARIS. It allows students from all over the world to talk directly with astronauts using amateur radio. This experience often inspires them to study science, technology, engineering, or math. IRIS includes teams from 9 different countries, including nations in Europe, along with Japan, Russia, Canada, and the United States. In places where radio cannot be used, speakerphones are connected to ground stations that link the calls to the ISS. In the year 2011, a special documentary film called First Orbit was released. It told the story of Vostok 1, the very first spaceflight by a human around the Earth. The filmmakers recreated the same orbit using the ISS and filmed the view astronaut Yuri Gagarin would have seen. ESA astronaut Paolo Nespoli filmed most of the footage from space himself. The film included real audio from Gagarin's flight, provided by the Russian State Archive. First Orbit was shared with the world for free on YouTube that same year. In May of 2013, astronaut Chris Hadfield filmed a music video of David Bowie's song Space Oddity while aboard the ISS. This became the very first music video ever made in space. Later, in November of 2021, a virtual reality exhibit called The Infinite was announced. It gave people on Earth the chance to explore life aboard the ISS through an immersive VR experience. The ISS is a true symbol of international teamwork. Its parts were built in many different countries around the world. The Russian section includes modules like Zarya and Zvezda, which were made at the Khrushchev State Research and Production Space Center in Moscow. Zvezda was actually built way back in the year 1985 for a space station that was never launched. The United States section includes major parts like the Destiny and Unity modules, the large truss structure, and solar panels. These were built at NASA's facilities in Alabama and Louisiana. Before being launched into space, all these parts were assembled and prepared at the Kennedy Space Center in Florida. Other countries also made important contributions. The European Space Agency built the Columbus module in Germany. Japan built the Kibo module, and Canada worked with the United States to create robotic arms like Canadarm2 and Dextra. All these parts were sent to Florida to be prepared for launch. The building of the ISS officially began in November of the year 1998. At first, Russian modules launched and connected by themselves. The other modules were carried into space by the space shuttle and then attached either by robotic arms or during spacewalks. These are officially called extravehicular activities, or EVAs. By the 5th of June 2011, astronauts had performed over 159 EVAs to assemble the station, spending more than 1,000 hours working in space. The very first piece of the ISS, the Russian Zarya module, was launched on the 20th of November 1998 using a Proton rocket. Zarya provided power, steering, communication, and control. Just 2 weeks later, on the 4th of December, the American module Unity was launched aboard the Space Shuttle Endeavour. Unity connected to Zarya, linking the American and Russian parts of the station. Although this partnership was a major achievement, joining space modules built by countries that had once been rivals, these first two modules didn't have life support systems. That meant no one could live on the ISS yet. At the time, Russian cosmonauts were still living on the older Mir space station. That all changed in July of the year 2000, when the Zvezda module was launched. It had everything astronauts needed to live in space. Thanks to Zvezda, the ISS could finally support a full-time crew. The first team of astronauts, called Expedition 1, arrived in November aboard a spacecraft called Soyuz TM-31. Since then, the ISS has grown steadily, with new modules added over the years by both Russian rockets and the American space shuttle. The first long-term crew of the International Space Station, known as Expedition 1, arrived in the middle of two important space shuttle missions, STS-92 and STS-97. These missions were crucial because they added big parts to the station's support structure, called the Integrated Truss Structure. This structure helped the station communicate using a powerful Q-band system, gave better control to handle the growing weight of the US segment, and brought in more solar panels to generate electricity. During the next 2 years, the station continued to grow. A Russian Soyuz U rocket brought a new module called Pirs, which served as both a docking port and an airlock. Then, 3 different space shuttles, Discovery, Atlantis, and Endeavour, delivered several more essential pieces. They brought the Destiny Science Lab, the Quest airlock for spacewalks, and a giant robotic arm named Canadarm2. They also added more parts to the station's backbone structure. In the year 2003, a tragedy occurred. The space shuttle Columbia was lost during re-entry into Earth's atmosphere. This terrible accident grounded the rest of the shuttle fleet and put a pause on further construction of the space station. It wasn't until the year 2006 that building resumed. The Space Shuttle Atlantis flew the STS-115 mission and delivered the second big set of solar panels. After that, more parts were added during missions STS-116, STS-117, and STS-118. With all the extra power from the new solar panels, the station could now support even more modules. So, the US Harmony module and the Columbus lab from Europe were attached. Not long after, the first two parts of Japan's Kibo laboratory also arrived. In March of 2009, the final set of solar panels was installed during mission STS-119, completing the truss structure. A few months later, in July, STS-127 brought the last part of Kibo and a new Russian module named Poisk. Then, in February 2010, the Tranquility module arrived, along with a special observation room called the Cupola. In May of the same year, Russia added the Rassvet module, which came aboard the Space Shuttle Atlantis on mission STS-132. This exchange happened in return for Russia launching the very first US-funded module, Zarya, back in 1998. The last pressurized module for the American part of the station was Leonardo. It was brought in February 2011 by the final mission of Space Shuttle Discovery, STS-133. Years later, in July 2021, Russia added a major new science module named Nauka. Along with Nauka came the European robotic arm, which can move itself between different parts of the Russian section of the station. Then, in November of the same year, Russia added another module called Prichal. As of February 2025, NASA reports that the station now includes 43 different modules and elements. One of the station's most useful features is that it's modular, meaning new pieces can be added or removed to fit new goals and experiments. The very first part of the station was Zarya, which means sunrise in Russian. Launched in 1998, it was built in Russia but paid for by the United States. In the early days, Zarya handled power, storage, movement, and navigation. Now, as the station has expanded, Zarya mainly serves as a storage unit, both inside and in its external fuel tanks. Its design came from an older Soviet spacecraft called TKS, used in the Salyut space program. Unity, also known as Node 1, was the first US-built module of the station. It serves as a bridge between the Russian and American parts of the ISS. It is a round steel module built by Boeing and measures about 15 feet in width and almost 18 feet in length. It was made at NASA's Marshall Space Flight Center in Huntsville, Alabama. Unity was the first of 3 connecting modules, followed by Harmony and Tranquility, that form the core structure of the US side of the ISS. Zvezda, which means star in Russian, was launched in July 2000 and is the heart of the Russian segment. It was the first part that allowed humans to live aboard the ISS full-time, with systems for life support and emergency operations. Built by RKK Energia and launched on a Proton rocket, Zvezda is still the main control room for the Russian modules and the place where crews gather during emergencies. The Destiny Lab is the main research center for American science aboard the ISS. It was launched in February 2001 by Space Shuttle Atlantis during mission STS-98. Connected to Unity over 5 days, Destiny became NASA's first permanent lab in space since Skylab. Inside, astronauts carry out experiments in fields like medicine, physics, engineering, and earth sciences. It also includes key life support systems such as the oxygen generating system. The Quest airlock makes it possible for astronauts to go on spacewalks using either American or Russian spacesuits. Before Quest was installed, spacewalks were difficult because the suits required different systems. Quest, launched aboard Atlantis in July 2001 during STS-104, is a 20-foot-long module connected to Unity. It includes 2 sections, one for storing suits and gear, and another for astronauts to get ready and exit the station. Poisk, launched on the 10th of November 2009, is also known as Mini Research Module 2. It works as an extra airlock for the Russian segment and allows spacecraft like Soyuz and Progress to dock. It also helps transfer fuel and store Russian Orlan suits. Its hatches open inward, a safety improvement after earlier designs proved risky. At first, the ISS was only supposed to operate for about 15 years. But thanks to strong international support and its ongoing success, its mission was extended multiple times. Some of the oldest modules have now been in space for more than 20 years, which has raised concerns about how much longer they can keep functioning reliably. Russia has said it may leave the ISS program after the year 2025, though it plans to keep its modules running until at least 2028. In the past, NASA had thought about ending the station's mission in 2016, but contracts were extended, and by 2018, new legislation supported continuing the ISS until at least the year 2030. If commercial space companies aren't ready to take over by 2031, NASA might keep the ISS running even longer. NASA considered several ways to retire the ISS safely, letting it fall naturally, pushing it higher, or doing a controlled dive into the ocean. The safest option turned out to be a carefully planned descent into a remote area of the Pacific Ocean, sometimes called the spacecraft graveyard. At first, NASA thought about using a modified Russian Progress ship to guide the ISS down, but later decided to design a new spacecraft for the job. In January 2022, NASA announced that this new US deorbit vehicle would be launched in the year 2030 and used in January 2031 to bring the station down safely. This new vehicle will be based on SpaceX's Cargo Dragon, but it will be upgraded with a larger engine section and more than 40 small thrusters.